Over 300 million years ago, Earth's continents came together to form one immense landmass, Pangaea. Beneath a sky that would be unrecognizable to us today, this supercontinent was more than just an extraordinary piece of geology. It was a vibrant world with climates ranging from sprawling deserts to dense, untamed rainforests. As we retrace the forces that shaped Pangaea, we'll uncover the dramatic events that built it up and eventually pulled it apart. Pangaea, the giant supercontinent that existed over 200 million years ago, formed through a slow but massive geological process known as continental drift. This phenomenon, proposed by Alfred Wegener in the early 20th century, suggests that the Earth's landmasses were once united in a single vast expanse. They were gradually pushed apart by the movement of tectonic plates, the large slabs of the Earth's crust that float atop the semi-fluid mantle, causing continents to shift over millions of years. During the late Paleozoic era, around 300 million years ago, the world's continents began to collide with one another. This collision resulted in the formation of mountains and other significant geological features, ultimately leading to the assembly of Pangaea. The process was driven by convection currents in the Earth's mantle, which moved these plates in various directions. Notably, the collision of the ancient continents known as Gondwana and Laurasia marked the final stages of Pangaea's creation. At its zenith, Pangaea was surrounded by a vast ocean called Panthalassa. This ocean dominated the planet, with Pangaea occupying a central position. The consolidation of land made a variety of ecosystems possible, but also created considerable geological stress. This stress resulted in volcanic activity and seismic events, which were common during Pangaea's existence. Ultimately, Pangaea began to break apart approximately 200 million years ago during the Mesozoic era, leading to the formation of the continents we know today. This incredible journey of Pangaea not only reshaped the planet's surface, but performed a vital role in the evolution of life, as the changing landscapes allowed for new habitats and species to emerge over time. The formation of Pangaea, the massive supercontinent that existed approximately 300 million years ago, was the result of significant geological forces driven by the dynamic processes of plate tectonics. The Earth's crust is divided into several major and minor tectonic plates, which float atop the semi-fluid layer of the mantle below. Over millions of years, these plates have moved, collided, and separated due to the convection currents in the mantle. It is this movement that ultimately led to the amalgamation of the continents into Pangaea. At the heart of this process were two main types of plate boundaries: convergent and divergent. Convergent boundaries occur where plates push against each other, resulting in the formation of mountain ranges, such as the Andes. Conversely, divergent boundaries happen when plates move apart, allowing magma to rise and create new crust, as seen in the mid-ocean ridges. During the late Paleozoic era, the tectonic activity was particularly intense, causing land masses to collide. This collision led to the formation of extensive mountain ranges and the closure of ocean basins, effectively bringing together various regions into a single landmass. Another crucial factor in the formation of Pangaea was the process called subduction, whereby one tectonic plate is pushed beneath another. This not only influences volcanic activity, but also affects the overall arrangement of continents. The subduction zones contributed to the uplift of mountain ranges and the closure of inland seas, further consolidating the continents into one. The forces at play weren't just limited to the surface. The internal dynamics of the Earth, through processes like mantle plumes, also played a significant role in reshaping the planet's surface. Over time, Pangaea itself began to break apart due to the same tectonic forces that brought it together. This powerful cycle of formation and destruction showcases the active nature of our planet, illustrating how geological processes can create vast land masses while simultaneously reminding us of their transient existence. As the continents drift to their present positions, we begin to see the lasting effects of that ancient supercontinent, evident in geological features, fossil distributions, and climatic patterns today. The idea of Pangaea, the ancient supercontinent that existed around 300 million years ago, relies on a range of compelling evidence gathered from several scientific fields. One of the most significant pieces of evidence comes from geology. When scientists examine the rock formations and mountain ranges around the world, they can identify similar types of rocks and geological structures that exist in regions now separated by vast oceans. For example, the Appalachian Mountains in North America closely resemble the Caledonian Mountains in Scotland. Such similarities suggest that these landmasses were once part of a single massive continent. Moreover, fossil records play a crucial role in supporting the existence of Pangaea. Fossils of the same species have been discovered on continents that are now separated by oceans. The Mesosaurus, a freshwater reptile, is a prime example. Fossils of this creature have been found in both South America and Africa. It is improbable that this species could have crossed the Atlantic Ocean, indicating that those two continents were once connected, allowing such reptiles to thrive in a common habitat. Another intriguing piece of evidence comes from paleoclimate data. Certain coal deposits, which form in warm, swampy environments, can be found in regions currently cold and polar, like parts of North America and Europe. This indicates that these areas used to be situated closer to the equator, implying that they were once part of a unified landmass. Similarly, glacial deposits in now tropical regions indicate a history of glaciation when these continents were situated in different latitudes, again supporting the idea of a merged supercontinent. Lastly, the study of plate tectonics provides a framework for understanding how Pangaea broke apart. The movements of tectonic plates continue to shape our planet's surface. The gradual drifting of continents is a result of this tectonic activity and underlines the historical connectivity of landmasses. Overall, the combination of geological similarities, fossil records, paleoclimatic evidence, and our understanding of tectonics contributes to the rich tapestry of evidence supporting the existence of Pangaea, painting a remarkable picture of our planet's distant past. To understand how tectonic plate movements led to the formation of the supercontinent Pangaea, we first need to grasp the nature of the Earth's outer shell. The Earth's lithosphere, which is composed of the crust and the uppermost part of the mantle, is divided into large segments known as tectonic plates. These plates float and drift on the semi-fluid layer beneath them, behaving very much like rafts on a vast ocean. Around 300 million years ago, during the late Paleozoic era, these tectonic plates were not in their current positions. Instead, they were slowly moving towards each other. This movement was driven by a process called mantle convection. Warm material from the Earth's interior rises to the surface, cools, and then sinks back, creating a circular motion. This movement exerts force on the tectonic plates, causing them to collide, pull apart, or slide against one another. As these plates interacted, they began to converge, pushing landmasses closer together. Over millions of years, different regions of land that had been isolated by oceans and other barriers gradually came into contact. The collision of plates not only caused land to stitch together, but also resulted in significant geological activity. Mountain ranges, like the Appalachian Mountains and the Himalayas, were formed through these tectonic collisions, further configuring the landscape of the Earth. By the time Pangaea was fully assembled, it represented nearly all of the Earth's dry land in a single vast expanse. This unification created a unique environment, characterized by a variety of climates. As Pangaea eventually began to break apart around 200 million years ago, it started to form the continents we recognize today. The legacy of tectonic movements solidified our planet's surface and reshaped our ecological and geological history, illustrating the profound and dynamic nature of Earth's processes over geological time. The formation of Pangaea, the ancient supercontinent that once unified much of Earth's land masses, spans an extensive timeline. Geoscientists suggest that Pangaea began to take shape during the late Paleozoic era, approximately 300 million years ago. This period marked the final assembly of various land masses through tectonic plate movements, culminating in a vast land area surrounded by a single ocean known as Panthalassa. The bulk of Pangaea remained intact during most of the late Paleozoic and into the early Mesozoic era. About 200 million years ago, during the Triassic period, it reached its peak size. Scientists believe that the configuration of Pangaea had profound effects on the planet's climate, ocean currents, and the distribution of flora and fauna. The vast interior of the supercontinent likely experienced extreme weather conditions, leading to significant adaptations among living organisms. However, Pangaea did not last indefinitely. Around 180 million years ago, during the Jurassic period, it began to break apart. This fracturing was driven by the movements of tectonic plates beneath the Earth's surface. The once mighty supercontinent gradually drifted into separate landmasses we recognize today, such as Africa, South America, and North America. The legacy of Pangaea is not just a fascinating chapter in Earth's geological history. It also offers key insights into understanding continental drift and plate tectonics. Modern geology continues to explore the events that shaped our planet, revealing how ancient phenomena still echo in today's landscapes and ecosystems. Through the study of Pangaea, we gain a deeper appreciation for the dynamic processes that shape the world we inhabit. The formation of Pangaea, which occurred around 300 million years ago, shaped the Earth's geological landscape in profound ways. Prior to Pangaea's existence, the continents were scattered, creating a more fragmented landmass. The joining of these landmasses into a supercontinent not only altered the distribution of land and water, but also influenced climate patterns, ocean currents, and the evolution of life on our planet. As Pangaea formed, the collision of tectonic plates led to significant geological activity. Massive mountain ranges, such as the Appalachians and the Urals, were born from this continental drift, a testament to the immense forces at play. Additionally, the merging of continents created vast inland seas and altered coastlines, contributing to the formation of unique ecological zones. These changes provided various habitats that fostered biodiversity, setting the stage for the evolution of numerous plant and animal species. However, Pangaea did not remain static. It began to break apart approximately 200 million years ago, leading to the formation of the modern continents. This fracturing and separation reshuffled ecosystems and contributed to the current arrangement of the Earth's land masses. The rifting process allowed magma to rise and create new ocean basins, further altering the geography. As tectonic plates shifted, they redefined coastlines and caused volcanic and seismic activities, adding layers of complexity to our planet's surface. Today, the legacy of Pangaea is still evident in the geological features we observe. The alignment of mountain ranges, patterns of earthquakes, and even the distribution of fossilized flora and fauna across continents underscore the lasting impact of this ancient supercontinent. Understanding Pangaea's formation and its aftermath not only sheds light on Earth's past, but also helps us comprehend the dynamic processes that continue to shape our planet today. The formation of Pangaea, the supercontinent that existed during the late Paleozoic and early Mesozoic eras, was a monumental event in Earth's history, woven into the vast tapestry of plate tectonics. The major tectonic plates involved in this process included the North American plate, South American plate, Eurasian plate, African plate, Indian plate, Australian plate, and the Antarctic plate. Each of these plates played a crucial role as they gradually shifted and collided over millions of years. Around 300 million years ago, these plates began to converge in a complex dance, driven by the dynamic forces beneath the Earth's crust. The North American plate moved southward, while the Eurasian plate drifted southward as well. Simultaneously, the African plate, which was closely aligned with the South American plate, began to interact with these northern plates, creating a giant landmass that would become Pangaea. This orchestration of movement significantly altered the planet's geography and climate. Another noteworthy factor in the creation of Pangaea was the subduction zones, where one tectonic plate was forced under another. This process not only contributed to the formation of mountain ranges, like the Appalachians and the Urals, but also led to volcanic activity that would shape the prehistoric landscape. The collisions and interactions of these plates caused the Earth's crust to fold and buckle, resulting in the dramatic geological features we still study today. Over time, the once unified Pangaea began to split apart due to ongoing tectonic activity. This division gave rise to the continents we recognize now, forever altering the course of Earth's biological evolution. Understanding the complex interactions of these major tectonic plates not only reveals the history of Pangaea, but also highlights the ever-changing nature of our planet's surface. Imagine a time over 300 million years ago when our planet looked vastly different from how we see it today. The continents we recognize now were once part of a massive supercontinent known as Pangaea. Stretching from the north to the South Pole, Pangaea unified land masses that now occupy separate regions of Earth. This colossal expanse of land altered not just the geography, but also profoundly influenced the planet's ecosystems and climates. This colossal expanse of land altered not just the geography, but also profoundly influenced the planet's ecosystems and climates. The shape of the coastline during the time of Pangaea was strikingly different. Instead of the fragmented continents we have now, regions that are today separated by oceans were once connected. The once expansive shores of Pangaea formed fewer, broad coastlines that were characterized by vast cliffs, arid deserts, and swamps, which sat alongside tropical regions. As Pangaea fragmented into the current configuration of continents, these coastlines became more indented and complex, creating smaller bays and peninsulas. Moreover, the climate around the Pangaean coastline was unlike today's weather patterns. Much of the land experienced a temperate, humid climate, with large areas covered in dense forests and a rich diversity of plant and animal life. The interior regions of Pangaea, far from the ocean's influence, were extremely dry and formed expansive deserts that starkly contrasted with the lushness of the coastal areas. This diversity contributed significantly to the evolutionary pathways for numerous species during that era. As the continents drifted apart over millions of years, the reshaping of coastlines continued to evolve, forming the intricate geography we see today. The Atlantic Ocean gradually opened up, which not only altered coastlines but also created the conditions for new ecosystems to thrive. This dynamic history of our planet, marked by constant change, highlights the relentless forces of plate tectonics and the intricate dance of geography that has shaped the world we live in. During the time of Pangaea, a supercontinent that existed about 300 million years ago, Earth's geological landscape was dramatically different from what we know today. This colossal landmass united nearly all of the Earth's continents, banding them together like pieces of a jigsaw puzzle. As Pangaea formed, significant geological features began to take shape, many of which still influence our planet today. One of the most striking features created during this time was the Appalachian Mountains in North America. As tectonic plates collided to form Pangaea, immense pressure built up, leading to the rise of these mountains. The Appalachians are an ancient range, and their origins can be traced back to this era. Similarly, the Caledonian Mountains in Scotland and Scandinavia were formed under comparable conditions. These mountains represent a time when our planet was still very active, sculpting its surface through tectonic forces. Pangaea also influenced the formation of vast deserts. The interior of the supercontinent became arid, leading to the creation of massive desert landscapes like the Sahara of today. Additionally, during this period, extensive coal deposits formed in swampy regions, providing evidence of lush, thriving vegetation that supplemented the climate of Pangaea. The cycles of growth and decay in these rich environments contributed to the formation of significant fossil fuel reserves we rely on even now. As Pangaea eventually began to break apart approximately 150 million years ago, the remnants of its geological features continued to evolve and shift. The resulting formations, such as the Rocky Mountains, the Andes, and the Himalayas, emerged from the ongoing tectonic movement initiated during the time of Pangaea. The planet's geological history is essentially a tale of relentless change, rooted in this extraordinary era when continents came together and shaped the world we inhabit today. Geologists employ a variety of innovative techniques to study ancient formations like Pangaea, the supercontinent that existed around 300 million years ago. One of the primary methods involves the analysis of rock formations and fossils found in current continents. By examining the types of rocks present and their configurations, scientists can piece together the historical movements of tectonic plates that eventually formed Pangaea and caused its breakup. Geological dating plays a crucial role in this process. Scientists use radiometric dating to determine the age of rocks, which helps establish a timeline of when specific formations were formed. Additionally, stratigraphy, the study of rock layers, allows geologists to correlate layers from different regions, revealing how land masses were once connected. These techniques help scientists identify similarities in geological materials across different continents, reinforcing the idea that those lands were once part of a unified whole. Fossil evidence further enhances our understanding of Pangaea. The discovery of identical fossils of plants and animals on separate continents suggests they were once close together. For instance, the presence of the Mesosaurus, a freshwater reptile fossil found in both South America and Africa, points to a time when these land masses were joined. This fascinating correlation between life forms provides compelling evidence that continents drifted apart over millions of years. In recent years, technology has advanced the study of ancient formations significantly. Geologists now use computer simulations and geophysical methods to model past continental movements and the forces that shaped them. This modern approach allows for a more dynamic and comprehensive view of Earth's geological history, helping us appreciate not only the formation of Pangaea, but also the intricate dance of our planet's ever-changing landscape. Pangaea, the supercontinent that existed around 300 million years ago, is a fascinating case study for paleoclimatologists. Its formation brought together nearly all of Earth's landmasses into a single entity, profoundly influencing global climate patterns. While we often envision a single weather system covering such an expansive area, Pangaea exhibited a variety of climates, shaped by its size and geographical diversity. In the interior of the continent, the climate tended to be dry and arid. With ocean influences distant, vast stretches of land became hot during the day and cooler at night, leading to significant temperature fluctuations. These conditions favored the development of extensive deserts, where wind erosion sculpted the landscape, creating vast sandy plains and unique rock formations. The arid center stood in stark contrast to the coastal regions, where moisture from the oceans helped foster a more humid climate. On the coasts of Pangaea, particularly along the western edges, the climate was more temperate. These areas experienced more rainfall, supporting lush forests and diverse ecosystems. In the southern part of Pangaea, the climate was influenced by the positions of the poles, leading to glacial activity during certain periods. The presence of ice sheets indicated that even within the expansive reach of a single supercontinent, temperature extremes could exist simultaneously. The evolution of life during the time of Pangaea was closely tied to these climatic variations. As organisms adapted to their environments, we see the beginnings of diverse plant and animal life that would influence the planet's future ecosystems. The transition from this supercontinent to the fragmented continents we recognize today not only reshaped Earth's geology, but also its climate, setting the stage for the biodiversity we cherish. The colossal landmass of Pangaea, which existed around 300 million years ago, significantly influenced both climate and weather patterns on Earth. Being a supercontinent, Pangaea was so immense that it had a profound impact on ocean currents and atmospheric conditions. The sheer size of this landmass meant that vast areas were relatively isolated from oceanic influences, which are major drivers of weather and climate. With Pangaea's interior being far from oceans, regions in the center experienced extreme temperature variations. During the summer months, these areas would become intensely hot, while winter could bring freezing conditions. The lack of moderating ocean waters helped create these drastic swings in temperature, resulting in a climate more continental in nature compared to today's more balanced patterns. This characteristic would have led to diverse ecosystems ranging from arid deserts to lush forests depending on proximity to the sea. Moreover, Pangaea affected global wind patterns. The arrangement of the land altered the distribution of heat received from the sun, which in turn modified wind circulation over the planet. As weather systems began to develop differently across this supercontinent, the regions experienced unique climatic phenomena. For instance, certain areas may have seen increased precipitation, while others became more arid, allowing for a variety of habitats and evolutionary paths for the flora and fauna of the time. Ultimately, the immense size and unique configuration of Pangaea reshaped the planet's climate dynamics. Even today, studying these ancient patterns provides valuable insights into climate change and how large landforms influence weather systems, reminding us of the interconnectedness of Earth's geological and climatic history. The supercontinent known as Pangaea existed around 300 million years ago, and its formation brought about significant climatic variations across its vast expanse. Encompassing nearly all of the Earth's landmass, Pangaea created an incredible diversity of environments that were deeply influenced by its geography. The interior regions, far from the moderating effects of the ocean, faced extreme weather conditions. This meant hotter summers, colder winters, and arid deserts, which contrasted sharply with the more temperate coastal areas. The coastlines of Pangaea, meanwhile, were surrounded by warm, shallow seas that enabled vibrant ecosystems rich with marine life. The coastal regions enjoyed a milder climate, conducive to flourishing forests and abundant vegetation. This juxtaposition of austere interior climates and lush coastal ecosystems played a crucial role in shaping the types of flora and fauna that developed across the land. Furthermore, the placement of Pangaea influenced global wind patterns and ocean currents, which in turn impacted climate. As the continents converged into one massive landform, the distribution of heat across the Earth was altered. This also meant that many regions experienced seasonal migrations of climate patterns, leading to marked differences aligned with the seasons. As Pangaea eventually began to break apart, these climatic differences continued to evolve, influencing the evolution of life on Earth. The transformations set in motion during the time of Pangaea helped establish many of the ecosystems we see today, illustrating how the tectonic activity of the past has long-reaching effects on climate and biodiversity. The remnants of these ancient environments still echo in today's global climate patterns. During the era of Pangaea, a supercontinent that existed approximately 300 million years ago, the arrangement of land and sea played a significant role in shaping global climate. The consolidation of continents into one massive landform restricted the flow of ocean currents, which are crucial for regulating temperatures and weather patterns across the globe. With fewer coastlines to interact with, ocean currents were not able to circulate as effectively as they can today. These stagnant ocean currents led to dramatic temperature variations across different regions. For example, the landmass of Pangaea was situated close to the equator and extended into the polar regions, creating extreme climates. While the interior areas of Pangaea likely experienced intense heat and aridity, coastal regions saw more moderate temperatures thanks to the ocean, albeit with less influence from oceanic currents. This difference created vast deserts and lush subtropical areas, showcasing a wide range of environmental conditions that were heavily influenced by the ocean's limited circulation. Moreover, the disruption to ocean currents during Pangaea's existence also affected the distribution of nutrients in the oceans. A well-circulated ocean can transport essential nutrients from the depths to the surface, supporting marine life. In this case, the relatively stagnant waters may have hampered biological activity, influencing the evolution of marine ecosystems. This, in turn, would have rippled through the food web, affecting not just marine organisms, but terrestrial life as well. As Pangaea began to break apart about 200 million years ago, ocean currents were re-established, leading to a more interconnected global climate system. The shifting continents allowed for a more effective mixing of ocean waters, which helped stabilize temperatures and create more favorable conditions for life to thrive. The transition from a singular landmass to the continental arrangement we know today laid the groundwork for the interconnected climate we experience currently, emphasizing the profound impact of oceanic currents on our planet's climate history. The supercontinent Pangaea, which existed around 300 million years ago, presented a unique environment that significantly influenced the development of life. At that time, Earth's atmosphere had a different composition compared to today. Elevated levels of carbon dioxide, along with a richer supply of oxygen, created conditions that were conducive to abundant plant growth and supported a diverse array of animal life. This lush environment formed the foundation for a variety of ecosystems. The vast interior regions of Pangaea experienced extreme temperature variations due to the distance from the ocean. These fluctuations led to the evolution of specific adaptations among organisms. For instance, plants and animals developed strategies to cope with the heat in arid regions and the colder temperatures in higher altitudes. This adaptability played a critical role in shaping the diverse landforms and ecosystems that emerged during this period. Additionally, the location of Pangaea, straddling the equator, allowed for a warm climate with varied moisture levels, influenced by monsoonal patterns. This resulted in the formation of large swamps and forests, particularly in the southern and equatorial parts of the continent. This rich biodiversity provided essential resources for herbivores, and in turn, the carnivorous species that preyed on them, creating a complex web of life. Pangaea's eventual breakup, driven by tectonic activities, led to dramatic shifts in atmospheric conditions as well. As land masses drifted apart, they began to create new climates and habitats. This profound change not only affected the distribution of life, but also set the stage for the evolutionary paths that would follow. The legacy of Pangaea and its atmospheric influences can still be seen in the biodiversity and ecosystems we observe on Earth today. The diverse climates fostered by this continental drift contributed to the evolution of various plant and animal species, ultimately shaping biodiversity. Furthermore, the movement also had a significant effect on ocean circulation patterns. As the continents reconfigured, they began to influence how ocean currents traveled. These currents are vital for distributing heat around the planet and consequently play a crucial role in determining climate conditions. For instance, the creation of the Atlantic and Indian Oceans allowed warm water currents to flow differently, affecting the climates of surrounding land areas. Lastly, the breakup of Pangaea had long-lasting consequences that continue to resonate today. The shift in land masses influenced patterns of rainfall, seasons, and overall climate stability. Thus, the story of Pangaea is not merely a tale about tectonic plates. It is a narrative that illustrates how geological processes have shaped the climates and environments we recognize now, unfolding a fascinating chapter in the Earth's climatic history. Volcanic activity played a significant role in shaping the environment of the ancient supercontinent Pangaea. During the time when Pangaea existed, approximately 300 million years ago, intense volcanic eruptions were commonplace. These eruptions released large volumes of gases and ash into the atmosphere, which had profound effects on both the climate and the ecosystems of the time. One of the most immediate impacts of volcanic activity was the alteration of the climate. The ash and gases, particularly sulfur dioxide and carbon dioxide, could lead to a phenomenon known as volcanic winter. This occurs when ash blocks sunlight, causing temperatures to drop and creating harsh conditions for life. Conversely, the release of carbon dioxide could also contribute to warming, creating a volatile and unstable climate. Such variations would have made it challenging for many plant and animal species to thrive, influencing patterns of extinction and survival. The landscape of Pangaea was also significantly altered due to volcanic eruptions. Lava flows, ash deposits, and the formation of new landforms contributed to the ever-changing topography of the continent. This could lead to the creation of new habitats, which might support a diverse array of organisms. However, it also meant that some regions became inhospitable, disrupting existing ecosystems. The volcanic activity during the era of Pangaea had far-reaching environmental impacts. By altering climate conditions and reshaping the landscape, these eruptions not only affected the survival of many species, but also played a vital role in the geological and biological evolution of the planet. The legacy of this volcanic activity can still be seen today in various geological formations and ecological patterns across continents. During the time of Pangaea, which existed around 300 million years ago, the Earth looked markedly different from what we see today. This supercontinent encompassed most of the planet's land masses, creating extensive inland areas that were far from the moderating influence of oceans. As a result, many large deserts formed, primarily due to a combination of climatic factors, geological processes, and the sheer size of the continent. The vast landscape of Pangaea experienced significant climatic variations. The interior regions of the supercontinent were subject to extreme temperatures, with scorching heat during the day and chilling cold at night. Without large bodies of water nearby to provide moisture and stabilize temperatures, these inner areas became arid, resulting in the formation of large desert regions. Over time, the lack of rainfall created vast stretches of dry terrain, consisting of sandy expanses and rocky outcrops. The deserts of Pangaea were not just barren wastelands, they hosted unique ecosystems that adapted to the harsh conditions. Fossils indicate the presence of hardy vegetation, and life thrived in these arid environments. Among the inhabitants were early reptiles and numerous invertebrates, showcasing a surprising diversity. The landscapes would have featured shifting sand dunes and rugged canyons, creating an environment both harsh and beautiful. Eventually, as Pangaea began to break apart about 175 million years ago, these deserts transformed in tandem with the shifting climates and landscapes. The remnants of these ancient deserts can still be traced in the rock formations and fossil beds we study today, offering us a glimpse into a time when the Earth's land masses were united, teeming with life amidst vast and unforgiving landscapes. When the ancient supercontinent of Pangaea formed around 300 million years ago, it created a vast, interconnected landmass that dramatically influenced the planet's climate and biodiversity. At that time, Pangaea was located near the equator, which allowed for a warm climate across large areas. This warmth fostered an explosion of life, with lush forests teeming with diverse flora and fauna. As a result, many species thrived, adapting to the varied environments from arid deserts to wet rainforests. However, as time progressed, the climate began to shift dramatically. The geological forces that had brought Pangaea together were still at work, leading to the slow breakup of the continent. This tectonic activity not only altered landforms, but also changed ocean currents and weather patterns. As parts of Pangaea drifted, some regions became more arid, while others experienced increased precipitation. Such changes in climate created new ecological niches, allowing some species to flourish while others struggled to survive. This dynamic environment led to significant evolutionary changes. Species that adapted to new conditions thrived, while others faced extinction. The changing climates also meant that habitats were fragmented, isolating populations and leading to unique adaptations over time. This process of isolation can result in speciation, where new species emerge from common ancestors in response to different environmental pressures. The eventual breakup of Pangaea about 180 million years ago further intensified these effects. As the continents drifted apart, the biodiversity of life became even more varied. Some species became widespread, while others remained isolated on their respective landmasses, developing unique traits tailored to local conditions. The legacy of Pangaea reminds us how closely intertwined climate, geography, and biological diversity truly are, shaping the rich tapestry of life we see on Earth today. The ancient supercontinent of Pangaea, which once brought together nearly all of Earth's landmass, has left a lasting impact on our planet's climate patterns today. When Pangaea began to break apart around 200 million years ago, it dramatically changed the distribution of land and sea. These shifts profoundly influenced weather patterns, ocean currents, and the development of ecosystems that we still see reflected in our climate today. One significant effect of Pangaea's breakup is the current arrangement of continents and how they interact with the global climate system. For instance, the vast Atlantic Ocean formed when Pangaea split, resulting in changes to oceanic circulation patterns. These patterns are essential for regulating temperature and weather systems across the globe. The Gulf Stream, which warms the eastern coast of the United States, and similar currents showcase how the geography of ancient land masses has shaped modern-day climatic conditions. Additionally, the distribution of mountains which arose during the time of Pangaea plays a crucial role in climate. The uplift of the Himalayas, for example, not only created a significant barrier to air masses, but also influenced monsoon patterns in South Asia. Such mountain ranges have a sizable impact on precipitation distribution, leading to the development of semi-arid regions where moisture fails to reach. These geographical features remind us of how the Earth's history continues to resonate through climate zones today. Finally, the remnants of Pangaea's ecosystems, such as tropical forests and arid deserts, hint at the ancient climate conditions that have evolved into today's diverse environments. Fossil records reveal how certain regions, once warm and lush, have transformed into arid areas due to geographic and climatic changes over millions of years. Studying these patterns not only clarifies our understanding of the Earth's climate history, but also allows us to better predict future climatic shifts in our ever-evolving world. During the time of Pangaea, which existed approximately 300 million years ago, the supercontinent was a rich tapestry of diverse plant life. The climate varied greatly across its vast expanse, from lush tropical forests to arid desert landscapes. This diversity was crucial, as it fostered an environment where various species could evolve and thrive. In the moist, warm equatorial regions, towering tree-like plants known as giant club mosses grew abundantly. These impressive plants resembled modern-day ferns and could reach heights of up to 100 feet. Their growth contributed significantly to the formation of coal deposits that we rely on today. Alongside them thrived cycads, which are ancient seed-producing plants that looked similar to palms. These hardy plants enjoyed the malleable conditions of Pangaea, adapting successfully as climates changed around them. In contrast, the cooler regions of Pangaea were dominated by conifers, such as early pine and sequoia-like trees. These evergreen trees have needle-like leaves, which help them conserve water, making them well-suited for drier conditions. Their presence not only contributed to the varied ecosystems of the continent, but also inspired the evolution of many herbivore species that would come to rely on these plants for sustenance. As Pangaea began to break apart about 180 million years ago, the plant life that had thrived during its existence set the stage for the rich biodiversity we see today. By occupying various ecological niches and adapting to different environments, these ancient plants laid the groundwork for future terrestrial ecosystems, influencing the evolution of both flora and fauna on our planet. The legacy of Pangaea's plant life continues to echo through the ages, underscoring the complex and interconnected web of life on Earth. During the time of Pangaea, which existed around 300 million years ago, the landscape was dramatically different from what we see today. This supercontinent brought together diverse ecosystems that flourished in a variety of climates ranging from arid deserts to lush tropical forests. The dominant plants of this era were significantly different from the flora we are accustomed to now, reflecting the unique environmental conditions of the time. Most notably, Pangaea was home to towering ferns, cycads, and the first true conifers. These groups of plants thrived in the warm and humid climate of the supercontinent. While modern forests are characterized by a rich diversity of flowering plants, the flora of Pangaea was predominantly non-flowering. The absence of angiosperms, which have since become the most widespread plant group, meant that the landscape was filled with thick undergrowth of ferns and spore-bearing plants, creating a very different visual and ecological environment. Additionally, the carbon dioxide levels during the time of Pangaea were significantly higher than today, which led to a different atmospheric composition. This abundance of carbon dioxide, combined with the lack of substantial ice at the poles, contributed to a warmer overall climate, fostering the growth of vast coal-forming swamps. These swamps, rich in decomposing plant matter, were crucial in creating the fossil fuels we rely on today. As plants played a pivotal role in carbon cycling, the distinctive ecosystem of Pangaea helped shape the planet's climate. As the continents broke apart and shifted into their current positions, the flora evolved to adapt to new conditions. Today's forests reflect a balance of flowering plants and gymnosperms, adapted to a range of climates and habitats. The contrast between the ancient flora of Pangaea and modern plant life illustrates the dynamic nature of our planet's ecosystems and highlights the intricate relationship between geological changes and biological evolution. During the time of Pangaea, which existed about 300 million years ago, the world looked remarkably different than it does today. This massive supercontinent brought together diverse ecosystems and allowed for the evolution of unique species. The most dominant animal species were primarily representatives of ancient amphibians and reptiles, as well as early ancestors of mammals. Among the most notable were the amphibians. During the late Paleozoic era, amphibians thrived in the lush environments that Pangaea offered. These creatures were larger and could be found in various forms, resembling modern-day salamanders and frogs. They flourished due to the availability of abundant fresh water and a warm climate, allowing them to evolve into a range of shapes and sizes, some even reaching impressive lengths. Additionally, reptiles began to make their mark during this time, particularly with the rise of the earliest archosaurs, which are ancestors of both dinosaurs and modern birds. These reptiles adapted well to the arid environments that were developing as the climate changed, marking a significant diversification in the animal kingdom. This period saw the emergence of distinct species that would later give rise to the formidable dinosaurs that would dominate Earth millions of years later. The Pangaean era represented a critical evolutionary chapter. Animals like giant amphibians and fierce early reptiles set the stage for future biodiversity. Their presence laid the groundwork for the dramatic shifts that followed, ultimately leading to the rich tapestry of life we observe today across our planet. The legacy of these ancient species continues to influence the world in which we live. The formation of Pangaea, which occurred around 300 million years ago, had a profound impact on the evolution of life on Earth. As a supercontinent, Pangaea brought together land masses that had previously been separated by vast oceans. This merging of continents created new habitats and significantly altered the climate across the globe. With a more uniform landscape and climate conditions, various species began to adapt in unique ways, ultimately fostering diverse evolutionary paths. One of the most significant results of Pangaea's formation was the connectivity it provided for terrestrial animals. Species that once evolved in isolation found themselves sharing environments with others. This led to increased competition and, consequently, the accelerated evolution of certain traits. For instance, herbivores adapted to new plant types, while predators evolved alongside them, influencing their survival strategies and ecological roles. As the continent began to break apart about 180 million years ago, it provided even more diverse environments such as mountains, deserts, and coastlines. These geographical changes played a crucial role in the speciation process, where species evolved differently in response to new environments. Isolated by emerging oceans, many groups of organisms followed divergent paths, allowing for the explosion of biodiversity that we observe in the fossil record today. The legacy of Pangaea is evident in the distribution of fossils and the evolutionary history of various species. Animals like dinosaurs thrived in the relatively uniform environment created by the supercontinent, but as Pangaea fragmented, the descendants of these ancient species adapted to new conditions and environments, leading to the rich tapestry of life we see on Earth now. The story of Pangaea is not just about continental drift. It's a pivotal chapter in the ongoing chronicle of life's evolution. During the time of Pangaea, which existed around 300 million years ago, the Earth was a very different place. This gigantic supercontinent brought together a range of unique ecosystems that thrived in various climates and environments. The sheer size of Pangaea meant that it encompassed vast deserts, dense forests, and large inland seas, each teeming with distinctive flora and fauna. In the heart of Pangaea, you'll find immense forests dominated by towering trees like the giant club mosses and seed ferns. These plants grew in warm, damp regions, creating lush canopies that provided shelter for a variety of organisms. Early reptiles, amphibians, and insects flourished in these ecosystems, showcasing a diversity of life that would lay the groundwork for future evolutionary developments. The variety of species found in these forests would eventually give rise to many of today's mammals and birds. Adjacent to these forests, the continental interior of Pangaea also featured expansive deserts. These arid landscapes were characterized by harsh temperatures and limited water supply. Despite the challenging conditions, resilient life forms adapted to thrive in such environments. Among these were dinosaurs and other reptiles that evolved to withstand extreme droughts. The shifting climate and conditions across Pangaea fostered a number of unique adaptations, showcasing the remarkable versatility of life during this period. Meanwhile, the coastlines and seas surrounding Pangaea offered another rich ecosystem. Ancient marine environments were filled with diverse life forms, including amphibious reptiles and large fish that roamed the waters. Coral reefs began to form, providing habitats for various marine creatures. These contrasting ecosystems on Pangaea highlight how interconnected life can be as land and sea influenced one another, shaping the biodiversity that would emerge as the supercontinent eventually split apart. The legacy of these unique ecosystems continues to inform our understanding of evolution and the resilience of life on Earth. The vast supercontinent of Pangaea, which existed around 300 million years ago, presented a unique set of challenges and opportunities for the organisms inhabiting it. During this time, the geography was dramatically different from today, offering a range of climates, from tropical regions with lush forests to arid deserts. As animals navigated this diverse environment, they developed various adaptations that allowed them to thrive in the changing landscapes. In the more humid areas of Pangaea, many species evolved complex features suited to life in dense vegetation. This included adaptations like strong limbs for climbing and grasping, as well as heightened senses to locate food and avoid predators. These traits allowed animals to exploit forest habitats rich in resources. Conversely, in the drier regions, animals developed resilience to heat and methods for conserving water. Features such as larger bodies to minimize heat loss and specialized skin to reduce water evaporation became advantageous for survival. As the land began to shift and separate, some species continued to evolve unique traits, further enhancing their ability to adapt to both terrestrial and aquatic environments. The resulting diversity of life included reptiles, early mammals, and amphibians, which all demonstrated remarkable versatility. As these animals spread across the vast continent, they continued to adapt to local conditions, leading to the rise of ecologically specialized niches. Ultimately, the dynamic environment of Pangaea paved the way for evolutionary innovations that shaped the animal kingdom. Many of these adaptations laid the groundwork for the diverse array of species that would eventually inhabit the separated continents. Each adaptation was a testament to the resilience of life, showcasing the intricate connections between organisms and their environments throughout Earth's history. As the supercontinent of Pangaea began to take shape around 300 million years ago, it set the stage for a unique array of prehistoric life forms. This massive landmass brought together diverse ecosystems that fostered an incredible variety of flora and fauna. Among the most notable inhabitants of this era were the formidable predators that made their presence felt on the vast, interconnected land. In Pangaea, fierce carnivorous reptiles known as archosaurs, which included the ancestors of both modern crocodiles and birds, began to dominate the landscape. These creatures thrived in the various habitats that Pangaea offered, from lush forests to arid plains. Some of the most well-known predators from this time are the early theropod dinosaurs. These bipedal hunters, with their sharp teeth and agility, were among the apex predators, setting the stage for the reign of dinosaurs that would follow. As the Triassic period transitioned into the Jurassic period, other powerful predators like the ancestors of alligators and the early dinosaurs emerged. The large predatory dinosaurs such as Coelophysis began to roam this primordial landscape. These agile hunters likely hunted in packs, using their speed and coordination to bring down larger prey, showcasing the evolutionary adaptations that made them successful. In addition to these reptilian predators, Pangaea also hosted large amphibians and mammals that were significant during this time. Creatures such as the labyrinthodonts, which were amphibians with formidable jaws and a predilection for hunting smaller animals, added to the challenge faced by herbivorous species. The interplay between these predators and their prey during the Pangaean epoch illustrates a dynamic food web, where survival depended heavily on adaptation and environmental changes, setting a fascinating backdrop to the history of life on Earth. The extinction events that occurred throughout Earth's history had profound effects on the biodiversity of Pangaea, the supercontinent that existed around 300 million years ago. During this time, Earth experienced a series of environmental upheavals, including drastic climate changes, volcanic eruptions, and fluctuations in sea levels. Each of these factors contributed to significant shifts in ecosystems and had lasting implications for the variety of life forms inhabiting Pangaea. The most notable of these extinction events were the Permian-Triassic extinction and the Triassic-Jurassic extinction. The Permian-Triassic event, often referred to as the Great Dying, around 260 million years ago, proved catastrophic, wiping out an estimated 90% of all marine species and 75% of terrestrial species. This widespread loss of life dramatically reshaped the biological landscape of Pangaea, leading to a significant reduction in biodiversity. Species that had thrived for millions of years vanished, creating ecological vacancies that allowed for new forms of life to emerge and adapt in the aftermath of the crisis. As Pangaea began to break apart during the Jurassic period, these changes in biodiversity set the stage for evolution and innovation. The extinction events had stripped ecosystems bare, but from that desolation came the opportunity for new species to rise. Mammals, dinosaurs, and birds began to evolve, taking advantage of the newly available resources and niches left by their predecessors. This period of rapid speciation ushered in a diverse array of life forms, fostering ecosystems that would eventually lead to the richness of life we see today. Thus, the extinction events were not merely moments of loss, they were crucial turning points in Earth's history that catalyzed evolutionary processes. The impacts of these catastrophic events reverberated across Pangaea, altering the course of biodiversity and paving the way for the complex web of life that characterizes our planet in the present day. Through destruction, life found a way to adapt, thrive, and ultimately flourish. The fossil records from the time of Pangaea, the supercontinent that existed around 300 million years ago, provide a fascinating glimpse into life during an era when all Earth's landmasses were joined together. By analyzing these fossils, scientists can reconstruct ancient ecosystems, showing us how diverse and interconnected life was at that time. For instance, the discovery of similar fossilized plants and animals across different continents supports the idea that these regions were once part of a larger, unified habitat. The variety of fossils found on Pangaea reveals much about the climate and environments of that period. Fossils of large reptiles and lush plants tell us that Pangaea had a wide range of ecosystems, from tropical rainforests to arid deserts. Interestingly, these records also show how continental drift has influenced the evolution of species. As Pangaea began to break apart, the geographical separation allowed for the development of unique species on different land masses, leading to the incredible biological diversity we observe today. Furthermore, fossil records have uncovered evidence of significant events, such as mass extinctions that impacted life on Pangaea. The detailed layers of sediment and fossils tell a story of adaptation and survival through drastic changes in climate and geography. These records raise essential questions about resilience and evolution, highlighting how life has a remarkable ability to adapt, even in the face of catastrophic changes. Ultimately, the insights gleaned from fossil records serve as a reminder of the dynamic history of our planet. They reveal the interconnectedness of all living things and provide a window into a world that existed long before humans walked the earth. As we delve into these ancient narratives, we gain a deeper appreciation for the complex tapestry of life that has evolved over millions of years. The supercontinent Pangaea, which formed around 300 million years ago, provides a fascinating backdrop for understanding the migration of flora and fauna. During this time, the vast landmass connected diverse ecosystems that would have otherwise remained isolated. This unique configuration created pathways for plant and animal life to traverse enormous distances, allowing species to spread across territories in ways that are quite different from what we see today. Flora, or plant life, benefited significantly from the continental arrangement of Pangaea. Wind currents and oceanic patterns played crucial roles in seed dispersal. For instance, light seeds could be carried long distances by the wind, while buoyant seeds could float across water to establish new colonies on other landmasses. Additionally, larger terrestrial animals, such as herbivores, would have facilitated the movement of seeds by consuming fruit and dispersing seeds through their droppings. This symbiotic relationship between flora and fauna promoted genetic diversity and adaptation across the unified land. Fauna migrated across Pangaea through a network of rivers, mountains, and dense forests, which created various habitats that supported distinct life forms. Animals were not confined to small areas, allowing them to explore and adapt to different environments. As ecosystems changed due to climatic shifts, species would alter their ranges in search of food or suitable habitat, promoting further dispersal across the supercontinent. This gradual migration over generations allowed for the development of species uniquely adapted to their specific environments, while maintaining connections to their ancestral populations. Eventually, as tectonic plates shifted and Pangaea began to break apart around 175 million years ago, these once united ecosystems became isolated. Island biogeography then took over, leading to new evolutionary paths. The legacies of these ancient migrations still resonate today, with descendants of those early species found across separate continents, each uniquely adapted to their specific locales, reminding us of how interconnected life once was. The concept of Pangaea, the once supercontinent that existed about 300 million years ago, holds a captivating influence over ancient mythologies around the world. Many cultures have tales that reflect the idea of a primordial land where all living things were connected. suggesting that their understanding of the Earth's geography stemmed from a collective memory of this vast, unified landmass. This is particularly fascinating when we examine myths that describe creation or the origins of humanity, often emphasizing the interconnectedness of all life. For instance, in many Native American beliefs, there are stories that speak of a time before land was divided, where animals, humans, and spirits coexisted in harmony. These narratives echo the themes of unity and connectedness that align perfectly with the idea of Pangaea. They offer insights into how these ancient cultures viewed their relationship with the earth and each other, suggesting an intrinsic bond that transcends distance and division. Similarly, in various African myths, the concept of a great migration or journey of ancestors from a common homeland can be paralleled with the movement of land masses. Such stories not only highlight the migration patterns of early human populations, but also reflect a time when the Earth felt more homogeneous. The emergence of different cultures from a shared origin serves as a testament to humanity's quest for belonging and understanding of the Earth's history. Pangaea's legacy in these mythologies reminds us that while the continents have drifted apart over millions of years, the stories and the cultures they represent continue to resonate. These ancient tales serve as a bridge, linking us to our distant past and fostering a sense of unity, rooted in a shared origin that nurtures our curiosity about both our history and the planet we inhabit today. The concept of a supercontinent like Pangaea was born from the insights of early scientists who closely observed the Earth's features and fossil evidence. In the early 20th century, Alfred Wegener, a German meteorologist and geophysicist, played a pivotal role in developing this idea. He noticed a striking similarity between the coastlines of South America and Africa. This observation led him to propose that these land masses were once joined together in a single supercontinent, which he named Pangaea, meaning all lands in Greek. Wegener's hypothesis was not based solely on the jigsaw-like fit of continents. He also collected vital fossil evidence to support his ideas. Fossils of the Mesosaurus, a freshwater reptile, were found in both Brazil and South Africa, separated by vast oceans. This distribution suggested that these regions were once connected. Additionally, similar plant fossils, such as those of Glossopteris, were discovered across continents that are now widely separated, indicating that these lands must have been joined at some point in Earth's history. Despite his compelling arguments, Wegener faced considerable skepticism from his contemporaries. Many scientists were reluctant to accept the idea of continental drift because they lacked a mechanism to explain how the continents could move. It was not until the mid-20th century, with advancements in geology and the study of plate tectonics, that Wegener's ideas gained substantial acceptance. The revelation that the Earth's crust is composed of tectonic plates that float on the semi-fluid mantle provided the necessary explanation for the movement of continents. Today, the existence of supercontinents like Pangaea is well supported by a wealth of geological and paleontological evidence. Researchers can examine the alignment of geological features, patterns of earthquakes, and even the distribution of certain species. These findings affirm that continents have not always been stationary, but have shifted dramatically over millions of years, shaping the world as we know it today. The legacy of Wegener's hypothesis continues to resonate, revealing the dynamic and ever-evolving nature of our planet. Pangaea, the ancient supercontinent that existed around 300 million years ago, has shaped not only the geological landscape of our planet, but has also influenced the cultural narratives of indigenous peoples throughout history. Many indigenous cultures possess rich oral traditions that convey a sense of connection to the earth, often interwoven with the understanding of land formations, migration patterns, and ecological relationships. The concept of Pangaea, though not explicitly recognized, resonates with their cosmologies, reflecting a time when all lands were united and sharing a collective history. For many indigenous groups, land is not merely a physical space, but a living entity imbued with stories and ancestral significance. The separation of continents as we know them today can symbolically represent the dispersal of tribes and communities and their subsequent journeys. These stories often articulate deeper connections to their environments, suggesting that as regions split apart, so too did cultures and histories, each developing unique identities around specific ecosystems. This view gives a profound meaning to the geographical features observed today, attributing spiritual significance to mountains, rivers, and valleys. Interestingly, some indigenous narratives coincide with the scientific understanding of continental drift. Certain cultures articulate their creation stories with themes of movement and transformation of land, echoes of the geological processes that formed Pangaea and its eventual breakup. The wisdom in these traditions often emphasizes harmony with nature and illustrates how ancient peoples might have perceived the world as interconnected, long before modern science provided a formal framework for understanding those connections. Moreover, the study of Pangaea invites indigenous communities to reflect on their pasts and envision their futures amid climate change and environmental challenges. By understanding the historical shifts of continents, these cultures can develop strategies to navigate the present-day dispersal of their lands, reaffirming their connection to the Earth and each other. Thus, the legacy of Pangaea serves as a bridge between scientific inquiry and cultural identity, reminding us all of the ever-evolving story of our planet and its people. The breakup of Pangaea, the ancient supercontinent, began around 200 million years ago and had profound consequences for the planet's geography and ultimately human history. As Pangaea fractured, land masses drifted apart, creating new coastlines, mountain ranges, and ecosystems. This transformation set the stage for the diversity of flora and fauna we see today, but it also deeply influenced human migration patterns throughout history. As continents separated, distinct environments emerged, promoting various adaptations among human populations. For example, when the Americas separated from Europe and Africa, it led to isolated developments in both regions. These separations meant that humans in each continent evolved differently, resulting in diverse cultures, languages, and societies. Patterns of migration were heavily influenced by geographical barriers such as oceans and mountain ranges, shaping how populations spread and interacted. Over millions of years, these continental shifts have made routes for migration easier or more challenging. For instance, the rise of land bridges, such as Beringia, the path that connected Asia to North America during the Ice Ages, enabled the movement of early human populations into new territories. Meanwhile, the vast oceans created barriers that led to distinct evolutionary paths and cultural developments, particularly for island populations scattered across the Pacific. The breakup of Pangaea was not merely a geological phenomenon. It played a critical role in the unfolding story of humanity. It carved out the world's landscapes, shaped migration patterns, and influenced cultural development across the globe, ultimately laying the foundation for the diverse and rich tapestry of human history we observe today. The concept of Pangaea, a supercontinent that existed around 300 million years ago, has captured the imagination of modern media, leading to varied interpretations and depictions. Documentaries, animated films, and educational programs have often illustrated Pangaea as a colossal landmass where familiar continents coalesced into one. This visualization not only highlights the geological realities of plate tectonics, but also portrays a world where the barriers presented by oceans did not exist, inviting viewers to consider how ecosystems and climates would have interacted without such separations. In films and television, the depiction of Pangaea frequently serves as a narrative device to explore themes of connection and separation. For instance, some productions emphasize the fascinating ways species evolved and adapted before the continents drifted apart. By presenting dinosaurs wandering the vast landscapes of Pangaea or plants thriving in a uniform climate, these interpretations create a vivid picture of a dynamic Earth, inviting audiences to ponder the complex relationships between environments and living organisms. Educational platforms have also embraced Pangaea, using it as a tool to engage younger audiences in the science of geology and paleontology. Interactive maps and dynamic animations allow viewers to visualize the slow but monumental shifts of continents over millions of years. These presentations often emphasize the significance of Pangaea not just as a historical curiosity, but as a critical piece of the planet's geological puzzle that helps us understand current continental arrangements and the implications for today's biodiversity and climate. Finally, modern media doesn't shy away from discussing the implications of such geological shifts. The narrative often extends to touch on how the movement of continents continues to shape the Earth, affecting everything from tectonic activity to climate change. By weaving together these stories, modern media transforms the idea of Pangaea from a mere scientific concept into a compelling tale of our planet's past that invites viewers to consider their place in the ongoing story of Earth. The story of Pangaea, the supercontinent that existed over 300 million years ago, offers profound lessons for modern society. This ancient landmass exemplifies the immense power of change and adaptation in our planet's history. As Pangaea began to break apart, it significantly impacted climate, habitats, and the evolution of life. In understanding this dramatic transformation, we learn the vital importance of adaptability in the face of change. Just like the species that survived by developing new strategies for living in shifting environments, our society must remain resilient and open to change in order to thrive amidst ongoing challenges, whether they be climate-related or technological. Pangaea also reinforces the concept of interconnectedness. During its existence, the different regions of Pangaea were bound together, allowing species to migrate easily across vast distances. The eventual separation led to distinct evolutionary branches, which now populate our diverse ecosystems. This teaches us the value of global cooperation in addressing the pressing issues of our time, such as climate change, pandemics, and resource management. Just as ecosystems rely on the health of their interconnected parts, humanity too must foster collaboration across borders to tackle complex global challenges. Moreover, the breakup of Pangaea sparked significant geological activities, including the formation of mountains, earthquakes, and volcanic eruptions. These events remind us that Earth is a dynamic, ever-evolving planet. It is crucial that we recognize our role in this larger system. The lessons of Earth's geological history prompt us to cultivate a deeper respect for the natural processes surrounding us and encourage us to act sustainably rather than exploitatively. We are reminded that our actions have vast implications, stretching far beyond our immediate environment. Finally, studying Pangaea highlights the significance of scientific inquiry and the pursuit of knowledge. The unfolding story of our planet is revealed through geology, paleontology, and climate studies, fields that provide essential insights into how our world operates. This encourages a commitment to science and education as foundational pillars for the future. As society grapples with rapid advancement and complex issues, the lessons learned from Pangaea remind us that understanding our past, like the history of our planet, can illuminate pathways to a sustainable and connected future. The formation of Pangaea, a supercontinent that existed during the late Paleozoic and early Mesozoic eras, profoundly shaped the Earth's geography and influenced ancient trade routes and human connectivity. Approximately 300 million years ago, all of Earth's landmasses consolidated into this vast landmass. As Pangaea began to break apart around 175 million years ago, new coastlines, mountains, and river systems emerged, creating both challenges and opportunities for early civilizations. During the time Pangaea was coming apart, the emergence of new land connections and separations facilitated not only geographical transformations, but also cultural exchanges. Early humans, as they migrated across land bridges that formed during ice ages, were able to traverse vast distances with greater ease than before. These migrations allowed the sharing of ideas, languages, and innovations, linking previously isolated communities and fostering intricate social networks across continents. The breakup of Pangaea also led to the development of distinct ecosystems and natural resources that were unique to various regions. For traders and early civilizations, this meant that goods like spices, precious metals, and textiles could be sourced from different areas, prompting long-distance trade networks to flourish. Consequently, early trade routes were established, connecting the burgeoning civilizations of Africa, Europe, Asia, and later the Americas. The movement of goods encouraged cultural diffusion, enriching societies through the exchange of technologies and artistic ideas. Furthermore, the geographical shifts brought about by Pangaea's breakup meant that ancient navigators had to adapt their strategies for exploration and trade. Coastal routes became paramount, with, for instance, the Mediterranean Sea emerging as a crucial maritime conduit for trade. Over time, this led to the establishment of significant trade hubs, cities, and connections that played a vital role in the development of human connectivity and the intricate web of relationships that defines our shared history. Thus, the legacy of Pangaea extends beyond geology. It is intertwined with the very essence of human interaction through trade and cultural exchange. The concept of Pangaea, the supercontinent that existed around 300 million years ago, presents an intriguing lens through which to examine the formation of human cultures. At that time, of course, modern humans did not yet exist, but imagining a world where humanity evolved on a single landmass helps to illuminate how environmental and geographical factors shape cultures. As Pangaea existed, it provided a vast and diverse landscape. Different regions would have had varying climates, resources, and ecosystems. For instance, the arid interior would foster unique adaptations and lifestyles compared to the lush coastal areas abundant with marine life. Different human groups would develop their cultures in response to these environments, influencing everything from diet and shelter to social structure and spiritual beliefs. Furthermore, the connectivity of a supercontinent would facilitate the exchange of ideas and technology. As groups spread across different areas, they would still have opportunities to interact, share knowledge, and trade. This would lead to a rich tapestry of cultural practices, with elements blending and evolving over time. Imagine the vibrant exchange of stories, agricultural techniques, and artistic traditions occurring among these interconnected communities. However, we also know that as Pangaea began to break apart, the resulting isolation would lead to distinct cultural identities. As land masses drifted into separate continents, humans would adapt to their specific environments, further diversifying their cultures. This process of cultural evolution demonstrates the delicate balance between unity and diversity that has characterized human history, a story that continues to unfold as our global community grows ever closer while still respecting our unique roots. The discovery of Pangaea, the ancient supercontinent that existed around 300 million years ago, has fundamentally altered our understanding of geology and the dynamic nature of Earth's surface. Before this concept was widely accepted, many scientists believed that continents were static, fixed in place. The realization that these massive landmasses once joined together shifted our perspective on how geological processes operate and how they shape the planet. The theory of plate tectonics, which explains how the Earth's crust is divided into several plates that float on the semi-fluid mantle beneath, gained robust evidence through the study of Pangaea. This idea suggests that the movements and interactions of these tectonic plates lead to phenomena such as earthquakes, volcanic eruptions, and the formation of mountains. By piecing together the puzzle of Pangaea, scientists came to understand that continental drift is a continual process, reshaping the Earth over millions of years. Furthermore, the discovery of Pangaea has provided insights into the distribution of fossils and geological formations found across continents. Fossils of similar species have been discovered on continents that are now thousands of miles apart. This evidence supports the notion that these regions were once connected, allowing for the migration of species. Similarly, geological formations, such as mountain ranges in South America and Africa, display striking similarities, further illuminating how they were formed from the same ancient landmass. Pangaea also enhances our understanding of climate change throughout Earth's history. The configuration of continents influences ocean currents and atmospheric patterns, affecting global climate systems. Studying Pangaea gives scientists crucial clues about prehistoric climates, helping them model potential future climate scenarios. In this way, the study of Pangaea serves not only as a window into Earth's past, but also assists in framing our understanding of the ongoing processes that will define our planet's future. The myth of Pangaea, the ancient supercontinent that existed hundreds of millions of years ago, has profound implications beyond mere geology. Its concept sparked curiosity about the Earth's configuration, which in turn fueled a thirst for exploration and discovery among scientists and explorers alike. The idea that all continents were once joined ignited imaginations, leading many to ponder what ancient landmasses held in terms of culture, resources, and biological diversity. As explorers set sail across the oceans, this myth served as an inspiration, suggesting that there were connections to be found between distant lands. The realization that continents shifted and changed over time encouraged a deeper investigation into how cultures evolved and interacted across these vast, once-connected regions. It implied that the world was more interconnected than it appeared, prompting explorations not only for geographical knowledge, but also for understanding the migration of species and the sharing of human cultures. In the scientific realm, the notion of Pangaea laid the groundwork for the field of plate tectonics, which helped explain the movement of continents and the geological features we see today. This understanding led to significant discoveries about earthquakes, volcanic activity, and the formation of mountains. As more evidence was gathered, scientists began to appreciate the Earth's dynamic nature, which transformed how we view our planet and its history. Ultimately, the myth of Pangaea is a testament to the power of human imagination. It encouraged generations to ask questions, seek answers, and explore the unknown. This quest for knowledge not only expanded our geographical boundaries, but also deepened our understanding of Earth's past, shaping the scientific narrative for futures yet to be discovered. The breakup of Pangaea, the supercontinent that existed during the late Paleozoic and early Mesozoic eras, was influenced by a combination of geological processes primarily driven by plate tectonics. Approximately 300 million years ago, Pangaea formed as continents collided and fused together, creating a massive landmass. However, around 175 million years ago, these geological forces began to pull the continents apart. One key process behind this breakup was the movement of tectonic plates. The Earth's lithosphere is divided into several large and rigid sections known as tectonic plates, which float atop the semi-fluid asthenosphere. The heat from the Earth's interior causes convection currents that push these plates in various directions. As these movements intensified, they created rifts in Pangaea. These rifts marked the beginning of the fragmentation, leading to the gradual separation of land masses. Another important factor was the formation of oceanic basins. As Pangaea split apart, the Atlantic Ocean began to form. New oceanic crust developed at the mid-Atlantic ridge, a series of underwater mountains created by volcanic activity. This process, known as seafloor spreading, further drove the continents apart, leading to the widening of the Atlantic Ocean and the eventual isolation of continents such as North America and Europe. Over millions of years, these geological processes reshaped the Earth's landscape, resulting in the continents we are familiar with today. The breakup of Pangaea not only transformed the planet's geography, but also influenced global climate patterns and the evolution of life across different land masses. Each continent, now separated, developed its own unique ecosystems, setting the stage for Earth's rich biodiversity. The story of Pangaea's fragmentation begins deep within the Earth's crust, where tectonic plates are constantly on the move. Pangaea, the supercontinent that existed around 300 million years ago, was once a vast landmass made up of nearly all the continents we know today. Over time, the heat generated by the Earth's molten core created convection currents in the mantle, setting these tectonic plates in motion. This movement would eventually lead to dramatic geological changes, including the breaking apart of Pangaea. As the tectonic plates shifted, tension built up along the boundaries where they interacted. This resulted in geological forces that began to pull apart the supercontinent. Around 200 million years ago, during the Mesozoic era, Pangaea began to split into two smaller supercontinents, Laurasia in the northern hemisphere and Gondwana in the southern. This separation was not a smooth process. It involved violent earthquakes, volcanic eruptions, and the formation of new ocean basins as the land began to diverge. The process of rifting, where the continental crust stretches and fractures, played a crucial role in this separation. Large cracks opened up in the Earth's crust, allowing magma to rise and create new landforms. As these rifts widened, they formed the early stages of oceans, and the Atlantic Ocean began to take shape. Over millions of years, the continents drifted further apart, leading to the diverse layouts we recognize today. Tectonic movements continued to shape our planet long after the initial fragmentation of Pangaea. Continents continue to drift at a rate of a few centimeters each year, influenced by underwater geological activity and the dynamics of plate tectonics. This ongoing movement not only reveals the restless nature of our planet, but also showcases the intricate geological history that laid the foundation for the world we inhabit today. Over 200 million years ago, the Earth was dominated by a massive landmass known as Pangaea. This supercontinent brought together nearly all of the planet's land masses into one expansive collective. However, the story of the continents did not end there, as geological forces began to work their magic and set the stage for their eventual separation. The first continents to break away from Pangaea were North America and Eurasia, specifically the regions that we now identify as Greenland and northern Canada, as well as parts of what would become Europe. This initial drift began during the late Triassic period, around 200 million years ago. As the tectonic plates moved, it led to the gradual rifting, allowing the oceans, such as the Atlantic, to emerge and expand between these newly separated land masses. Following the initial split, the movement continued, and South America began to part ways from Africa. This period, known as the Jurassic, saw these continents drifting slowly apart, creating the foundation for the continents we recognize today. This process of continental drift resulted in significant changes to the Earth's geography, ecosystems, and climate over millions of years, with each continent taking on its unique characteristics. The shifting of the continents is ongoing, with tectonic plates continuing to move and shape the Earth's surface. Though the process can be imperceptibly slow from a human perspective, it highlights the dynamic nature of our planet and its ever-changing landscape. Understanding these early separations provides insight into not just the history of Earth, but also the evolution of life that has thrived across these separated lands for millions of years. The breakup of Pangaea was a monumental event in Earth's geological history, shaping the continents we know today. This massive supercontinent began to form about 300 million years ago during the late Paleozoic era, gathering together all the land masses in a single block. However, the story of Pangaea does not end there. It is perhaps more fascinating to consider how long it took for this grand structure to fracture. The process of Pangaea's breakup began around 180 million years ago, during the early Mesozoic era. Over the span of many millions of years, tectonic forces began to pull apart the once united landmass. The breakup was not a single, swift event. Rather, it occurred in multiple stages and involved complex movements of the Earth's plates. By about 150 million years ago, the initial rift between the northern continent of Laurasia and the southern continent of Gondwana had begun to take shape. Each phase of this breakup unfolded over tens of millions of years, leading to the gradual drift of continents. The separation of these massive land segments continues to this day, albeit at a slow pace. The Atlantic Ocean, for instance, continues to widen as the Americas drift further away from Europe and Africa. In terms of geological time, we reckon the entire process of Pangaea's breakup took around 100 million years. Even in the scope of Earth's history, that is a significant duration, illustrating the dynamic and ever-changing nature of our planet. The remnants of this grand supercontinent serve as a testament to the power of tectonic forces and remind us of a time when the Earth looked vastly different from how it does now. The fragmentation of Pangaea, which began about 200 million years ago, drastically reshaped the Earth's environment and ecosystems. As this colossal supercontinent split into smaller land masses, it altered ocean currents, climate, and habitats. The shift in geography created distinct environmental zones that had a profound impact on biodiversity. With the separation of continents, oceans expanded, allowing for the rise of new sea routes. This not only affected temperature regulation around the globe, but also initiated new weather patterns. These changes inevitably affected rainfall distribution, leading to certain areas experiencing increased aridity, while others became lush and tropical. This diverse array of climates facilitated the evolution of varied life forms adapted to these new environments, resulting in enhanced biodiversity. Additionally, the fragmentation led to isolated land masses, which often resulted in unique evolutionary paths among species. For instance, when South America separated from Africa, species developed independently, creating ecosystems rich in endemic flora and fauna. However, this also encouraged extinction events, as some species could not adapt quickly enough to their transformed surroundings or fled to new areas, leading to reduced genetic diversity. On land, we saw dramatic changes in habitats. Mountain ranges formed due to tectonic activity, while valleys and basins created new ecosystems, transforming how organisms interacted within their environments. The rise and fall of these geological features continued to influence climate and biodiversity long after Pangaea's breakup, making the legacy of this monumental event a pivotal chapter in Earth's environmental history. The breakup of Pangaea was a monumental event in the history of our planet. Around 200 million years ago, Earth was dominated by a single enormous supercontinent known as Pangaea. This vast landmass housed nearly all of the planet's terrestrial flora and fauna in one sprawling ecosystem. However, the forces of plate tectonics, driven by the intense heat from the Earth's interior, were slowly but surely altering the landscape. As Pangaea began to fracture, the continent started to drift apart due to tectonic movements. This splitting process led to the formation of the Atlantic Ocean and effectively separated what would become North America, South America, Europe, and Africa. The rifting did not happen at once. It took tens of millions of years, characterized by volcanic activity, earthquakes, and the gradual shaping of continental boundaries. These geological upheavals allowed new ocean avenues to form, shaping coastlines and affecting climates across the globe. In addition to merely changing the physical locations of land masses, the breakup of Pangaea had profound impacts on biodiversity and ecosystems. Isolated land areas evolved distinct flora and fauna, leading to the rich variety of species we see today. For example, the separation of Madagascar from the African mainland allowed unique species like lemurs to develop in isolation. Similarly, the split between South America and Africa led to evolutionary paths that resulted in dramatically different wildlife on either side of the Atlantic. Thus, the breakup of Pangaea was not just about moving land masses, it was a pivotal event that shaped the Earth's surface and its biological diversity. The process continues today, as continents like Africa and South America keep inching apart, reminding us that the planet is ever evolving. Understanding this transformation gives us insight into not only how our continents formed, but also how they will continue to change long into the future. The breakup of Pangaea, the supercontinent that existed around 300 million years ago, is a significant event in Earth's geological history. Scientists employ a variety of modern technologies to study this ancient phenomenon, providing insights into how our planet's continents drifted apart over millions of years. One key technology is plate tectonics modeling. This involves using computer simulations to visualize the movement of tectonic plates. By inputting current geological data, scientists can recreate the positions of continents over time. These simulations help researchers understand how forces within the Earth, like mantle convection and gravitational pulls, have shaped the land we see today. Geophysical tools play a crucial role as well. Instruments like seismic sensors allow scientists to study the Earth's crust by measuring waves generated by earthquakes. By analyzing these waves, researchers can map the structure of the Earth's interior and identify boundaries between tectonic plates. These findings shed light on how the continents functioned within Pangaea and how they eventually broke apart. Another remarkable technology is satellite geodesy, which uses GPS systems to precisely measure the movement of the Earth's surface. Through this technology, scientists can observe how quickly the plates are currently drifting apart and compare the data to historical movements. This ongoing research not only enhances our understanding of Pangaea's breakup, but also helps us predict future geological changes, deepening our appreciation for the dynamic nature of our planet. Fossil evidence has been a crucial element in deciphering the history of our planet, particularly in the narrative of Pangaea's breakup. Pangaea, the supercontinent that existed around 300 million years ago, is believed to have been a single landmass that eventually split apart to form the continents we recognize today. The collective work of paleontologists and geologists has unveiled a compelling story through the distribution of fossils across separated landmasses. One of the most striking pieces of evidence comes from the discovery of similar fossils across continents that are now thousands of miles apart. For instance, the fossil remains of the Mesosaurus, a freshwater reptile, have been uncovered in both South America and Africa. Since this creature could not have traversed the vast oceans that separated these landmasses, it strongly suggests that these continents were once joined together, allowing Mesosaurus to inhabit a continuous habitat. Similarly, fossils of the Glossopteris plant have been found in regions scattered across South America, Africa, India, Australia, and Antarctica. This plant thrived in a more temperate climate and could not have survived in the conditions presented by the oceans surrounding these continents today. The presence of such fossils on disparate landmasses provides substantial evidence that Pangaea once allowed for a shared ecosystem, which subsequently changed as the continents drifted apart. These fossil discoveries not only support the theory of continental drift, but also help scientists understand the climatic and ecological transformations that occurred as Pangaea fractured. The evidence underscores how interconnected life on Earth was during that ancient period, revealing a dynamic planet that has undergone dramatic shifts over geological time, shaping the diverse world we inhabit today. The breakup of Pangaea, the supercontinent that existed around 250 million years ago, had significant impacts on ocean patterns and marine life. As Pangaea fragmented into the continents we recognize today, it initiated profound changes in ocean currents and coastlines. These shifts altered the distribution of heat and nutrients in the oceans, leading to variations in marine ecosystems. One major effect was the creation of new ocean basins, which modified existing ocean currents and their flow patterns. The opening of these basins, like the Atlantic Ocean, changed the dynamics of water circulation. Warm waters from the equator began to circulate differently, influencing climate and weather patterns around the globe. This also means that marine life had to adapt to a range of new environments, leading to the evolution of new species uniquely suited to these changes. Additionally, the separation of continents created isolated regions where marine life could evolve independently. This isolation led to biodiversity in the oceans as species became specialized to their unique habitats. For instance, organisms like corals flourished in newly formed shallow seas, while others adapted to deeper water conditions created by the movement of the plates. The end result was a more diverse and complex marine ecosystem than had ever existed before. The breakup of Pangaea set the stage for modern oceanic geography and the distribution of life within the oceans. The legacy of this monumental event can still be seen today, as the patterns of ocean currents and marine biodiversity continue to shape the ecosystems that exist in our oceans. Understanding how these systems evolved provides crucial insights into the health of our planet's oceans and the organisms that call them home. The supercontinent Pangaea existed around 300 million years ago, bringing most of Earth's landmasses into one colossal landform. Before its breakup, all the continents were fused together, creating a single massive land area that spanned the equator to the polar regions. This enormous assembly of land affected climate, ocean currents, and the distribution of plants and animals. Vast deserts, lush forests, and mountain ranges were interconnected, leading to a relatively uniform biodiversity across this giant landmass. With the gradual breakup of Pangaea, beginning roughly 180 million years ago, the continents began to drift apart, resulting in significant changes to their shapes, positions, and ecosystems. As they moved, they formed new coastlines and reshaped ancient geological features. For instance, the Atlantic Ocean emerged between what are now North America and Europe, disrupting the previously unified habitats and leading to distinct evolutionary paths among species that had once shared a common environment. After the breakup, continents began to assume their modern configurations. This shift not only altered local climates but also influenced ocean currents, which began to develop unique patterns. With new coastlines created and distances between landmasses increasing, species became isolated, leading to the evolution of diverse ecosystems that we see today. Australia, for example, drifted away from Antarctica and developed unique flora and fauna, while Africa became a cradle for many large terrestrial animals, markedly distinct from their counterparts in the Americas. The differences before and after Pangaea's breakup were profound, shaping our planet's geography, climate, and biological diversity. The fragmentation resulted in new evolutionary pathways and ecological niches, painting a vibrant picture of the dynamic nature of Earth's continents through the ages. Each shift not only marked a geological event, but laid the groundwork for the rich tapestry of life that continues to evolve today. Studying ancient supercontinents, such as Pangaea, involves a fascinating blend of scientific disciplines and modern technologies. Geologists use several scientific methods to piece together the history and movement of Earth's continents. One of the most fundamental techniques is plate tectonics, which examines the movement of Earth's lithospheric plates. By understanding how these plates shifted over millions of years, researchers can unravel the complex story of how Pangaea formed and eventually broke apart. Another effective method is paleomagnetism. When volcanic rocks are formed, their magnetic minerals align with the Earth's magnetic field. By studying the magnetic orientation of these ancient rocks, scientists can deduce the latitude at which they formed. This provides crucial information about the ancient position of continents relative to one another. The patterns of ancient magnetism offer deep insights into how landmasses have drifted over time. Geological mapping and the analysis of rock layers also play a significant role in this research. By examining sedimentary rocks, scientists can identify patterns and sequences that reveal the conditions of Earth's past climates and ecosystems. This helps to reconstruct how the environment has transformed since the time of Pangaea. Fossils found within these layers provide additional clues about the flora and fauna that existed during that era, shedding light on the biological diversity that thrived on this colossal landmass. Lastly, advancements in computer modeling and simulations allow scientists to visualize and predict the dynamics of continental movements. These models take into account various factors, such as tectonic forces and geological processes. Such innovative approaches enable researchers to create scenarios of how ancient supercontinents like Pangaea may have looked and behaved, giving us a glimpse into the deep past of our planet. Through these combined scientific methods, we gain a richer understanding of Earth's history and the forces that have shaped our world over hundreds of millions of years. Our understanding of Pangaea, the ancient supercontinent that existed around 300 million years ago, has transformed significantly over time, thanks to advancements in technology. Initially, scientists relied on visual observations and geological studies to piece together the puzzle of continental drift. Early evidence was based on the matching shapes of coastlines, as well as similar fossils and rock layers found on different continents. This foundational work offered hints of a past where all landmasses were joined together, but it was challenging to form a cohesive picture. The introduction of plate tectonics in the mid-20th century marked a turning point in our understanding. This revolutionary theory explained how Earth's lithosphere is divided into several plates that float on the semi-fluid asthenosphere beneath them. With this framework, scientists could better comprehend the movement of continents over geological time. Earthquake patterns and volcanic activity provided more data, all supporting the idea that continents were not static but dynamic, affected by the forces of plate tectonics. As technology progressed further, tools such as satellite imagery and advanced computer modeling emerged. This high-resolution imaging allows for detailed mapping of the ocean floor, revealing the mid-ocean ridges and subduction zones that define plate boundaries. Moreover, geophysical methods like seismic imaging provide insights into the structure of the Earth's crust. These data have allowed scientists to recreate the movements of the continents with greater accuracy and to understand the processes that led to Pangaea's formation and eventual breakup. Today, with the power of computer simulations and the ability to analyze vast amounts of geological data, our perspective on Pangaea has evolved into a more intricate narrative. We can visualize the continental configurations over millions of years and understand the climatic and biological impacts of this massive landmass. As we continue to refine our technological tools and methods, our grasp of Pangaea and the forces that shaped it will undoubtedly deepen, providing a clearer picture of our planet's past. Satellite observations have revolutionized our understanding of Earth's ancient geography, particularly the configuration and dynamics of the supercontinent Pangaea. By utilizing advanced technologies such as remote sensing and radar, scientists can trace the remnants of Pangaea and gain insights into its structure and movement. These observations allow researchers to measure landforms, analyze geological features, and study the tectonic shifts that shaped our planet over millions of years. One of the most significant contributions of satellite technology is its ability to map Earth's surface with remarkable accuracy. This precision helps geologists identify ancient coastlines, mountain ranges, and other significant land features that can be compared to present-day geography. Such comparisons reveal clues about how continents have drifted and transformed since Pangaea began breaking apart around 200 million years ago. This process of continental drift is key to understanding not only the history of our planet, but also the geological processes that continue to shape it today. In addition, satellite data enables scientists to detect subtle changes in the Earth's crust, which can indicate ongoing tectonic activity. By studying these geological movements through time, researchers can piece together a more comprehensive picture of how Pangaea functioned as a supercontinent. They can track the rates of movement and interactively visualize the ancient configurations of land and sea, providing a vivid context to the story of our planet's evolution. Furthermore, satellite observations also play an essential role in understanding the ancient climates that existed during the time of Pangaea. By analyzing vegetation patterns and sediment structures, scientists can infer climatic conditions that prevailed across vast regions. This holistic understanding helps illuminate not just the geography, but also the ecosystems that thrived then, revealing how changes in geography influenced biological evolution. Ultimately, the role of satellite technology in studying Pangaea exemplifies how modern science continually enhances our grasp of the Earth's complex past. Scientists seeking to understand the ancient supercontinent of Pangaea employ a fascinating blend of geology, paleontology, and modern technology to recreate its environmental conditions in laboratories. To start, they gather geological data from rocks and sediment that date back to the time of Pangaea, which existed around 300 million years ago. This information helps them to establish what the climate was like, the types of ecosystems that thrived, and how the geography shaped life during that era. In laboratories, scientists use climate simulation models to replicate atmospheric conditions of Pangaea. These models consider factors such as temperature, precipitation, and even wind patterns. They can recreate the warmer climate that dominated much of Pangaea and explore differences in temperature and precipitation across various regions. The results provide insights into how ancient climates influenced the distribution of flora and fauna, offering a clearer picture of life on this massive landmass. To simulate the ecosystems, researchers also turn to paleobiology. This involves examining fossils and other biological evidence to understand what types of plants and animals existed during the time of Pangaea. By cultivating similar plants in controlled conditions and studying their growth patterns, scientists can gain insights into how these organisms might have thrived in the environmental conditions of the ancient world. This allows them to visualize the biodiversity that characterized the supercontinent. Finally, sedimentology plays a crucial role as scientists analyze ancient sediment layers for clues about environmental conditions. By studying how sediments were deposited and the types of minerals present, they can infer the climatic conditions that led to the formation of the continent's varied landscapes. This comprehensive approach reveals not just the physical aspects of Pangaea, but also the dynamic ecosystems that flourished, further illuminating our understanding of Earth's geological history. Recent discoveries have significantly enriched our understanding of Pangaea, the ancient supercontinent that existed around 300 million years ago. Research into geological formations, fossil records, and plate tectonics has unveiled a more intricate history, suggesting that Pangaea was not just a singular event, but part of a cyclical pattern of continental drift. This means that oceans opened and closed, and continents came together and broke apart over millions of years, shaping Earth's surface in dynamic ways. Fossil evidence has played a crucial role in piecing together Pangaea's vast geographical story. Paleontologists have found identical fossil species on continents now separated by oceans, which suggests these landmasses were once joined. For instance, fossils of the ancient reptile Mesosaurus have been discovered in both South America and Africa. This intriguing similarity implies that these two continents were connected during the time of Pangaea, allowing species to inhabit both areas. Another remarkable discovery involves the study of ancient climates preserved in rock layers. These formations reveal the past climates of regions that were once part of Pangaea, providing insights into how this supercontinent influenced global weather patterns. For instance, the presence of coal deposits in Antarctica indicates that this region once enjoyed a temperate climate, supporting lush vegetation. Such findings help scientists understand the ecological impact of continental configurations. Moreover, advancements in technology, like detailed satellite measurements and computer simulations, have made it easier to visualize the movements of continents. These tools highlight how land masses shifted and rotated over millions of years, leading to the Pangean breakup that began about 200 million years ago. Interestingly, this ongoing movement continues to shape our planet, reminding us that Earth's surface is far from static. Together, these revelations deepen our appreciation for the complex history of Pangaea and its lasting legacy on the planet we inhabit today. Computer models play a crucial role in understanding the ancient supercontinent Pangaea and its eventual breakup. By using the principles of plate tectonics, scientists can simulate the movements of Earth's tectonic plates over millions of years. These models rely on detailed geological data, allowing researchers to create a visualization of how continents drift, interact, and reconfigure themselves throughout geological history. The foundational aspect of these simulations lies in the movement of lithospheric plates. These plates float on the semi-fluid asthenosphere beneath them, and even slight temperature fluctuations can lead to significant movement over extensive periods. Through computer models, scientists can input various geological conditions, including the temperature of the mantle and the forces exerted on each plate, to observe how these elements contribute to the gradual formation and disintegration of Pangaea. Additionally, computer models can incorporate various geological events, such as volcanic eruptions and the formation of mountain ranges. These factors not only influence the movement of tectonic plates, but also impact climate, sea level, and biodiversity throughout the ages. With the use of such simulations, researchers can assess how changes in one area might trigger shifts in another, offering a more comprehensive view of Earth's geological timeline. Ultimately, the ability to visualize the past through computer simulations aids scientists in unraveling the complex history of our planet. The breakup of Pangaea is not just a tale of drifting land masses. It reveals the dynamic and interconnected nature of Earth's systems. These models allow us to appreciate how the forces of nature have shaped the world we live in today. Reconstructing the history of Pangaea, the supercontinent that existed around 300 million years ago, presents a host of challenges for scientists. Firstly, the geological record is often incomplete. Rock formations can be eroded or buried deep beneath layers of sediment, making it difficult for researchers to piece together a continuous narrative of the continent's past. Not all geological events are preserved in the rock record, leading to gaps that can complicate overall understanding. Another significant challenge lies in the movement of tectonic plates. The Earth's surface is dynamic, with continents shifting over millions of years. This movement can obscure the original locations of land masses, complicating the task of reconstructing their positions from ancient times. Scientists must rely on a combination of geological evidence, fossil records, and plate tectonics to infer how these shifts occurred, and sometimes the data can lead to different interpretations and hypotheses about Pangaea's configuration. Fossil evidence provides a vital clue in this historical puzzle, but comes with its own set of complications. For example, similar fossils found on now distant continents suggest that these landmasses were once connected, yet determining the exact pathways of these ancient organisms involves a careful analysis of the environments in which they thrived. Discrepancies in fossil records can lead to debates among scientists as they assess the age, distribution, and ecological contexts of these organisms. Lastly, advances in technology, such as satellite imagery and computer modeling, have improved our understanding, yet remain limited by the inherent complexities of geological history. Dealing with the vast timescales involved and the slow processes of geological change can lead to uncertainty. Despite these obstacles, each discovery adds a new piece to the puzzle, enriching our comprehension of how Pangaea formed, existed, and ultimately broke apart, shaping the world as we know it today. Interdisciplinary research has played a crucial role in enhancing our understanding of Pangaea, the ancient supercontinent that existed around 300 million years ago. By combining insights from geology, paleontology, and paleoclimatology, scientists have constructed a more comprehensive picture of how this massive landform came to be and what its existence meant for life on Earth. Geology allows researchers to analyze the ancient rock formations and tectonic movements, revealing how the continents were once fused together. Paleontology provides valuable evidence through the fossil record, showing how plant and animal species were distributed across different regions before Pangaea began to break apart. For instance, Fossils of similar species found in now widely separated continents like South America and Africa indicate that these land masses were once joined. By examining how life evolved in response to the changes in climate and geography during and after the existence of Pangaea, scientists gain insights into the dynamics of evolution and extinction. Paleoclimatology, the study of past climates, complements these fields by revealing how the climate across Pangaea influenced its ecosystems. By analyzing ancient sediments and ice cores, researchers can reconstruct climate patterns and how they affected the distribution of species. This layered understanding highlights the intricate relationships between climate, geography, and biology, allowing scientists to piece together Earth's history in ways that single-discipline research often cannot. Through collaborative efforts, these various scientific fields create a mosaic of information that not only enlightens us about Pangaea's formation and dissolution, but also sheds light on the broader processes that have shaped our planet. The interconnectedness of these disciplines illustrates how understanding our world requires looking beyond traditional boundaries, revealing the remarkable complexity of Earth's history. As we explore the mysteries of Pangaea, the ancient supercontinent that once united nearly all of Earth's landmasses, we find ourselves on the brink of exciting advancements in technology that could deepen our understanding of its formation and eventual breakup. One such technology is advanced satellite imaging. This remarkable tool enables us to create incredibly high-resolution maps of the Earth's surface. With the help of satellite data, scientists can analyze geological features, observe subtle shifts in land formations, and reconstruct ancient environments with unprecedented clarity. This could reveal how Pangaea's landscapes transitioned over millions of years. Another promising technology lies in the realm of geophysical imaging. Through methods like seismic tomography, researchers can peer beneath the Earth's crust, allowing for the visualization of the structure and composition of tectonic plates. This approach will not only enhance our comprehension of Pangaea's past, but also illuminate the ongoing processes that are shaping our planet in real time. By understanding these deep Earth dynamics, we could gain insights into how continents moved apart and how they might shift again in the future. Genomics, particularly through the study of ancient DNA, also holds the potential to revolutionize our understanding of the flora and fauna that existed during Pangaea's time. Advances in sequencing technologies enable scientists to extract genetic material from fossilized remains and even sediments. This information can clarify how ecosystems evolved as continents drifted apart, revealing the biodiversity that once thrived in a globally connected environment. The remnants of life from that era inform us about ancient climates and the adaptability of species, providing a clearer picture of evolutionary processes. Finally, interdisciplinary collaborations are harnessing the power of big data and artificial intelligence. By collating and analyzing vast amounts of climatic, geological, and biological data, these technologies can detect patterns and interconnections that were previously unrecognized. As more data emerges, AI algorithms can assist researchers in predicting how similar tectonic movements may occur in the future or how they impacted past climate changes. With these transformative technologies at our disposal, our comprehension of Pangaea and Earth's geological history is set to expand exponentially. Modern geological maps serve as essential tools in visualizing the ancient supercontinent known as Pangaea by providing a detailed look at the Earth's rock layers, compositions, and the shifts that have occurred over millions of years. These maps highlight the distribution of various rock types and ages, allowing scientists to compare the geological features across different continents. By examining these attributes, they can piece together the puzzle of how the continents were once joined together before drifting apart. One of the most compelling insights from these maps is the matching geological features found on separate continents. For instance, when looking at the eastern coast of South America and the western coast of Africa, similarities in rock types, mountain ranges, and fossil records emerge. This evidence strongly supports the idea that these continents were once part of a unified landmass. Geological maps illustrate the remnants of ancient landforms, presenting a unified picture of the Earth's history that stretches back hundreds of millions of years. Using advanced technology, today's geologists can layer this data to create three-dimensional models of the Earth's crust. This helps in visualizing how continental plates have shifted over time, revealing the pathways that led to the current configuration of continents. It allows us to comprehend the dynamic nature of our planet, portraying how land once covered by vast forests or towering mountains fragmented and relocated, eventually forming the continents we recognize today. By analyzing the geological evidence alongside paleontological data, scientists piece together ecological systems that existed when Pangaea thrived. Tracks of ancient life, such as dinosaurs, can be traced across different continents, supported by the alignment of geological formations. In this way, modern geological maps do not merely depict Earth's surface, but serve as a window into its deep past, allowing us to marvel at the grandeur of continental drift and the intricate tapestry of life that has emerged as the world evolved. The study of Pangaea, the ancient supercontinent that existed around 300 million years ago, offers remarkable insights into the Earth's geological history and the processes that shape our planet. Understanding Pangaea allows scientists to track the movements of tectonic plates over vast periods of time. This knowledge is crucial as it helps us decipher how continents drift and reshape themselves, illustrating the dynamic nature of the Earth's surface. By examining how Pangaea broke apart, researchers have gained a deeper understanding of plate tectonics. The slow but relentless movement of these tectonic plates creates new geological features while also destroying existing ones. For instance, the rifting of Pangaea led to the formation of ocean basins and mountain ranges we recognize today. By studying these processes, scientists can make educated predictions about how current configurations might evolve. Moreover, the geological evidence left behind by Pangaea, such as the distribution of fossils and mineral deposits, provides clues about past climates and ecosystems. This historical context can be applied to address current changes. By understanding the conditions under which continents formed, drifted, and eventually reshaped one another, scientists can better anticipate the potential effects of contemporary geological activity, including earthquakes, volcanic eruptions, and the scenarios triggered by climate change. Finally, Pangaea also teaches us about the interconnectedness of different regions of the Earth. As continents collide and split apart, they influence ocean currents and atmospheric conditions. Monitoring current geological activity in relation to the knowledge gained from Pangaea helps predict future changes. Consequently, this ancient supercontinent serves not only as a fascinating chapter of our planet's history, but also as a foundational pillar for predicting the Earth's geological future. Pangaea, the ancient supercontinent that existed around 300 million years ago, serves as a fascinating window into the intricate mechanics of our planet's tectonic plates. Understanding Pangaea offers profound insights into how these plates move and interact, and even how they may continue to evolve in the future. The breakup of Pangaea, which began around 200 million years ago, illustrates the dynamic nature of Earth's lithosphere, a constant dance of creation and destruction. This colossal landmass was not static. It drifted and shifted due to the forces of plate tectonics, which are driven by movements in the Earth's mantle. Over millions of years, the continents we know today emerged, drifting into positions that altered ecosystems, climates, and even ocean currents. As we study the geological records from this time, we gather evidence of past extinctions and changes in biodiversity that were linked to these shifts. What we learn is that tectonic plate movements are not merely historical events. They are ongoing processes that will shape the Earth far into the future. Fast forward to today, and scientists anticipate that tectonic plates will continue to shift in significant ways. The continents will gradually move further apart or even collide again, a process that can take tens of millions of years. For example, the Atlantic Ocean is widening as the American continents move away from Europe and Africa. Meanwhile, the collision between the Indian subcontinent and the Eurasian plate has led to the formation of the Himalayas. These shifts remind us that the Earth is alive, constantly evolving under our feet. The future of tectonic plate movements could potentially lead to the formation of a new supercontinent, a phenomenon that occurs roughly every 400 to 600 million years. Some scientists suggest that the current plates might eventually draw together to form a landmass known as Pangaea Proxima. Understanding Pangaea helps us to appreciate not only our planet's history, but also its future. prompting us to contemplate the long-term environmental and ecological effects of these slow but powerful geological forces. It challenges us to reflect on humanity's fleeting existence in comparison to the vast timeline of Earth's continuing evolution. As we gaze into the distant future, the Earth's land formations may indeed come to resemble the ancient supercontinent of Pangaea. This prospect arises from the relentless movement of tectonic plates, which are the gigantic slabs of Earth's crust that float on the molten mantle beneath. Currently, these plates drift at a pace so slow that it is often imperceptible in a human lifetime. Yet over millions of years, these subtle shifts can culminate in significant geographical changes. In about 200 million years, estimates suggest that the continents may converge again, propelled by the ever-shifting dynamics of our planet's interior. Researchers hypothesize scenarios where the Atlantic Ocean could shrink, pushing the Americas closer to Europe and Africa. This converging of landmasses could create a new supercontinent, akin to Pangaea, with vast inland areas and diverse ecosystems emerging from the reconfiguration of oceans and land. Interestingly, the processes influencing land formation extend beyond mere plate tectonics. They also encompass climate change, sea level fluctuations, and even volcanic activity. As the climate alters, certain regions may become more suitable for life, dictating where land might rise or where it might subside over geological timescales. This harmony of geological and climatic forces suggests that although the physical layout of continents will shift, many ecological communities and biomes may find ways to adapt. Thus, the idea that our future Earth could mirror the dramatic layout of Pangaea is both fascinating and plausible. As we explore these geological transformations, we come to appreciate the dynamic nature of our planet, a testament to the intricate interplay of time and nature that continues to sculpt the world we know. What lays ahead remains a mystery, but understanding the forces at work today can provide valuable insights into the landscapes of tomorrow. The ancient supercontinent of Pangaea, which existed around 300 million years ago, provides valuable lessons about the profound effects of climate change on Earth's ecosystems and geology. At its peak, Pangaea brought together diverse environments and climates, influencing atmospheric conditions and the distribution of flora and fauna. This unity had significant consequences, including shifts in climate patterns and biodiversity loss, reminding us of how interconnected our planet's systems really are. As Pangaea drifted apart, geographical barriers began to shape distinct environments, leading to the evolution of species in isolation. However, the shift from a single landmass to separate continents created varied climates, from sprawling deserts to lush rainforests, illustrating how geographic changes can drive biodiversity. Today, we recognize that similar patterns apply in our era of climate change, where rising temperatures and changing weather patterns threaten habitats and species survival across the globe. Moreover, Pangaea's environmental impact reminds us of the balance required in nature. The formation and breakup of the supercontinent altered ocean currents and weather systems, showcasing how climate systems are delicately interconnected. When one part of the system is disrupted, it can cause ripple effects throughout the entire planet. This underlines the vital importance of a holistic approach to tackling climate change, focusing not just on localized efforts, but also on understanding global environmental interdependencies. Lastly, the lessons from Pangaea highlight the concept of resilience and adaptation. As species adapted to the changing environments during and after the breakup of this supercontinent, we too must evolve in response to current climate challenges. By learning from the past, we can better equip ourselves to develop sustainable practices and technologies, transforming our relationship with the planet. As we navigate through these turbulent climatic times, the history of Pangaea serves as a crucial guide for our future. The concept of a future supercontinent has fascinated scientists and geologists alike, as it presents intriguing possibilities for Earth's biodiversity. As tectonic plates continue to shift, the gradual merging of continents could reshape habitats, altering ecosystems on a global scale. This dramatic geological change may lead to both opportunities and challenges for various species. When continents come together, they can create vast expanses of land. This new environment might foster the emergence of unique habitats. Large areas of land can support diverse flora and fauna, potentially leading to an increase in biodiversity. Species may thrive in the newly formed ecosystems, where evolutionary processes can lead to new adaptations. However, the neighboring regions of a supercontinent might undergo significant transformation as well, which can threaten existing species. The converging of ecosystems could result in competition for resources, affecting the survival of certain species. On the flip side, the creation of a supercontinent could result in habitat fragmentation. As species adapt to changing landscapes, those unable to migrate or survive in the new conditions may face extinction. Any shifts in climate or geography could also disrupt established networks among species. For instance, some animal migratory patterns could be affected, leading to potential declines in populations if they cannot navigate the newly formed geographical barriers. The formation of a supercontinent presents a double-edged sword. It can enhance biodiversity by creating new habitats and opportunities for evolution, but it can also threaten the delicate balance of existing ecosystems. As scientists continue to study these scenarios, we gain valuable insight into not only the past, but also the future of life on our planet. The potential impact of changing tectonic configurations serves as a reminder of the interconnectedness of all species and their environments. Pangaea, the supercontinent that existed around 300 million years ago, offers a fascinating glimpse into Earth's dynamic geological history and a potential window into its future. During the time of Pangaea, the planet experienced significant geological upheaval, including massive volcanic eruptions and profound earthquakes that reshaped the landscape. These natural disasters were driven by the tectonic plate movements that ultimately broke Pangaea apart, illustrating how the Earth's surface is a living entity that constantly changes. As we look to the future, we can draw strong parallels to the cycles of movement and transformation evident in Pangaea's history. Today, tectonic plates continue to drift, a process that is both slow and relentless. This movement can accumulate stress over long periods, potentially leading to sudden releases of energy that result in earthquakes. Similar to the geological events of the past, we can anticipate that as the continents continue to shift, areas of the globe will experience increased seismic activity and volcanic eruptions. It's also worth considering climate change as an element akin to the environmental shifts experienced during Pangaea's existence. The supercontinent affected ocean currents and atmospheric circulation patterns, which in turn influenced climate, leading to periods of drought and increased storm activity. As our planet warms, we are beginning to see alterations in weather patterns that simulate these historical changes, which could trigger more frequent natural disasters such as hurricanes and floods. The story of Pangaea serves as both a reminder of the forces shaping our planet and a cautionary tale for the future. Earth's history shows us that natural disasters are not merely random occurrences, but rather integral components of the planet's health and transformation. As we navigate the complexities of a changing world, it's essential to recognize the long-standing interplay between geological processes and climate, as well as our own role in this intricate dance. Studying Pangaea, the supercontinent that existed around 300 million years ago, provides vital insights into the Earth's history and its ecosystems. This ancient landmass held nearly all of the world's land together, creating a unique environment where species flourished and evolved. By examining Pangaea, we can better understand how geological and climatic changes influence biodiversity. This knowledge is especially crucial in today's context, as we face similar but human-driven changes to our environment. Understanding the way species adapted to the vast and varied habitats of Pangaea informs our conservation strategies. For instance, researchers can trace the patterns of migration and evolution that occurred as continents drifted apart. These patterns show us how ecosystems can adapt or decline when faced with significant shifts. When we confront current environmental threats, such as climate change and habitat loss, we can take cues from the resilience displayed by ancient species. This can guide us in creating more effective conservation policies tailored to protect vulnerable ecosystems and species amid ongoing changes. Additionally, the study of Pangaea highlights the interconnectedness of life across the planet. When we look back at how organisms thrive together on this single landmass, we can recognize a fundamental principle. The health of one ecosystem often affects others. This perspective encourages a more holistic approach to conservation, urging us to consider the intricate web of relationships among species and their habitats. Protecting a single species or ecosystem in isolation may not be enough. Understanding and preserving those connections is key. By applying the lessons learned from Pangaea, conservationists are better equipped to address contemporary challenges. The fossil record serves as a reminder of the planet's dynamic nature and the importance of preserving biodiversity. As we strive to safeguard the Earth's future, these insights from our planet's distant past can inspire a deeper commitment to protecting the intricate tapestry of life that surrounds us today. The formation of another supercontinent similar to Pangaea would have profound implications for Earth's climate, ecosystems, and even human civilization. A supercontinent arises from the movement of tectonic plates, and while this process can take millions of years, the consequences would ripple across the planet in various ways. One immediate effect would be a significant change in global climate patterns. As land masses merge, the interior of the supercontinent would likely become dry and arid, creating vast desert regions. Conversely, coastal areas could experience a more temperate climate due to the influence of surrounding oceans. The reconfiguration of land and sea would also alter ocean currents, which play a critical role in regulating temperatures worldwide. This shift could lead to unexpected weather patterns, affecting agriculture and ecosystems. Ecosystems would also undergo dramatic transformations. The merging of continents could lead to the extinction of various species as habitats are disrupted. In contrast, some species may flourish in the newly formed environments. This could lead to a mix of species, some thriving in the new ecosystems while others struggle to adapt to the changing conditions. Biodiversity would be affected, reshaping the living tapestry of our planet. Human civilization would face its own challenges as well. If a supercontinent formed, it could influence migration patterns, resource distribution, and even the geopolitical landscape. Communities separated by vast oceans would find themselves reconnected, leading to cultural exchanges and potential conflicts over resources. The experience of the human race would undoubtedly alter, reminding us of our fragile place within the ever-evolving tapestry of Earth's geological history. The concept of Pangaea, the massive supercontinent that existed about 300 million years ago, fundamentally alters how we perceive the permanence of continents. Traditionally, we think of continents as stable, unchanging land masses, but the idea of Pangaea introduces a dynamic vision of Earth's surface. It suggests that the continents we recognize today were once part of a colossal land structure that eventually broke apart and drifted to their current positions. Continental drift, a key aspect of plate tectonics, supports this idea. The theory posits that the Earth's crust is divided into large plates that float on the semi-fluid mantle beneath them. Over millions of years, these plates have moved, collided, and separated, leading to the formation of oceans and the rearrangement of land masses. The shifting of these plates has been a constant process, indicating that our continents are not fixed, but rather in a state of continuous transition, albeit at a very slow pace. Fossil evidence further reinforces the concept of Pangaea. Species that were once widespread across various continents can now be found in isolated regions, suggesting that these land masses were connected in the past. For example, fossils of the Mesosaurus, a freshwater reptile, have been discovered in both South America and Africa, signifying that these continents were once joined. Such findings indicate a historical movement, directly challenging the notion that continents remain static over geological time. Ultimately, the story of Pangaea and the movement of continents encourages us to rethink our understanding of the Earth's geological timeline. It paints a picture of a planet characterized by change and transformation, reflecting a dynamic past that continues to influence the surface we live on today. Understanding this concept can deepen our appreciation for the Earth's history, revealing that the landscape we see is just a snapshot in an ongoing geological saga. As the process of continental drift advances, we can envision several future scenarios that will dramatically reshape our planet. Current geological evidence shows that the continents are slowly but steadily moving, driven by the forces of plate tectonics. Over millions of years, this movement could lead to the creation of new mountain ranges, the formation of vast ocean basins, and even the eventual merging of land masses. For instance, if the current trajectory continues, we might witness the continents of Africa and Europe gradually colliding, which could lead to the uplift of a new mountain range reminiscent of the Himalayas. This colossal geological event would not only change the landscape, but could also impact weather patterns and biodiversity in the region, creating new ecosystems while threatening existing ones. Meanwhile, the Americas are drifting further away from Europe and Africa. This separation may eventually open the Atlantic Ocean even wider, altering ocean currents and climate conditions on both sides. These changes could have profound implications for marine life, potentially leading to changes in fish populations and the health of ocean ecosystems in general. The long-term future holds a fascinating possibility known as supercontinent formation. Scientists speculate that every few 100 million years, the continents converge to form a single landmass. The next supercontinent, sometimes referred to as Pangea Proxima, may emerge within the next few 100 million years, dramatically altering global geography and continuously influencing life on Earth. Through this lens, the gradual drift of continents serves as a reminder of our planet's dynamic nature, forever evolving and reshaping our world in ways we are just beginning to understand. The idea of a single landmass, often referred to as Pangaea, has significantly impacted our philosophical understanding of unity and connectedness. Historically, the notion of a singular, vast landmass that later fragmented into separate continents suggests that all human beings share a common origin. This perspective reinforces the philosophical idea that, despite our cultural and geographical differences, we are fundamentally linked by our shared past. In exploring the implications of this unity, scholars and thinkers have drawn connections between our physical separation and the artificial divisions we create through borders and cultures. The concept of Pangaea serves as a poignant reminder that the Earth, in its natural state, was once a singular entity. This can inspire us to reconsider our approach to global issues, encouraging collaboration and empathy among diverse communities. It invites the question, if we were once a part of the same land, can we not strive toward a shared future? Additionally, the metaphor of Pangaea extends beyond mere geography into the realms of ecology and interdependence. Just as the continents had to adapt and evolve separately, so too have we as societies. This fragmentation has led to a rich tapestry of cultures and philosophies. However, understanding our collective roots can foster a sense of responsibility toward one another and the planet. It reflects our interconnectedness, urging us to think globally and act in ways that benefit all. Thus, the concept of a single landmass is not just a historical geological phenomenon, it is also a philosophical lens through which we can examine our unity or lack thereof. By recognizing that we originated from a singular point on the Earth, we can better appreciate the importance of solidarity in addressing contemporary challenges, from climate change to cultural disputes. This understanding essentially beckons us towards a future that acknowledges our shared heritage and mutual responsibilities. The era of Pangaea, a time when all of Earth's continents were joined together as one massive landmass, provides a unique lens through which we can contemplate our planet's past and its present. One personal insight we might gain is the transient nature of our environment. Pangaea existed for millions of years before breaking apart, reminding us that change is an inevitable part of history, both on a geological and personal level. This realization can prompt us to embrace the shifts and transformations in our own lives, understanding that just like the continents, our circumstances are never static. Another fascinating aspect of contemplating Pangaea is the sense of interconnectedness it fosters. During its existence, the diverse organisms shared habitats and ecosystems that would later become isolated. This serves as a metaphor for humanity's own need for connection. In our increasingly fragmented world, recognizing that we once shared a single landmass might inspire us to find common ground with each other, promoting global cooperation and understanding despite our apparent differences. Moreover, reflecting on Pangaea can deepen our appreciation for Earth's biodiversity. As the continents drifted apart, unique ecosystems evolved, leading to the vast array of life we see today. This can provoke thoughts about our role in preserving the environment and protecting endangered species. It encourages us to consider how our actions impact the delicate balance of life on our planet, echoing Pangaea's story of both unity and eventual separation. Finally, The era of Pangaea encourages us to think about the future. Just as the continents drift today, with tectonic plates gradually shifting, we can ponder the future implications of climate change and human impact on Earth. This era serves as a reminder that our actions today might significantly alter the planet for future generations. By contemplating Pangaea, we not only gain insights into our past, but also reflect on our responsibility to care for our world moving forward. Human curiosity about Pangaea, the supercontinent that existed around 300 million years ago, speaks to a fundamental desire to understand our planet's past and our place within it. Pangaea, with its vast landmass and diverse ecosystems, represents a time when life was unified on a single continent. This profound connection to our terrestrial history drives our exploration not just of Earth's geological changes, but also of potential homes beyond our planet. As we look back at the shifting plates that once formed Pangaea, we realize that Earth's dynamic system is ever evolving. This understanding sparks our interest in exploring other planets, as we wonder what secrets they might hold about their own geological past. Are there ancient landscapes similar to those of early Earth? Perhaps on Mars, the evidence of riverbeds or the surface features of Venus could tell us stories of once thriving environments. Each exploration mission brings us closer to answers that could illuminate our own history and evolution. Moreover, the fascination with Pangaea connects to the broader questions of habitability. If an ancient supercontinent could support such diverse life forms, what might we find in other locations in our solar system? The possibility of microbial life on icy moons like Europa or within the clouds of Venus becomes a tantalizing prospect. Each mission, be it to Mars or the outer reaches of our solar system, pushes the boundaries of our knowledge and reflects our longing to discover if we are alone in the universe. Ultimately, the curiosity about Pangaea not only highlights our evolutionary journey, but also strengthens our commitment to explore worlds beyond our own. Each time we gaze toward the stars, we carry with us the legacy of Earth's geological transformations and a hope. Perhaps one day, we might find new continents to explore in the cosmic expanse of space. Our past shapes our future, and our relentless quest for knowledge drives humanity to traverse new frontiers. The vision of Pangaea is a powerful concept that stirs the imagination. This supercontinent, which existed around 300 million years ago, united all the Earth's land masses into one colossal formation. By visualizing Pangaea, future generations of scientists and explorers can appreciate the dynamic nature of our planet and the interconnectedness of ecosystems across vast distances. It serves as a reminder that our Earth is not static but continually evolving through geological processes. Moreover, the story of Pangaea holds vital lessons for those studying climate change and environmental science. As scientists explore the impacts of shifting continents and changing climates over millions of years, they can draw parallels to current global challenges. Understanding the gradual movements of tectonic plates and their implications may inspire innovative solutions to mitigate the effects of human-induced climate change. The historical context of Pangaea could encourage a holistic view of environmental stewardship and the importance of preserving the planet's integrity. Pangaea also fosters a spirit of exploration and discovery. Imagining a world where all continents were once joined can ignite curiosity about ancient life forms and the biodiversity that thrived at that time. It prompts a desire to uncover the hidden histories written in rock layers and fossil records. This enthusiasm for discovery is crucial as younger generations take up the mantle of exploration, reinforcing the idea that every scientific inquiry is linked to a larger narrative of Earth's past and future. Finally, Pangaea serves as a metaphor for unity among humanity. Just as the continents once formed a single landmass, collaborating towards common goals could lead to significant advancements in science and exploration. Understanding our shared history on this planet might inspire collective efforts to address global issues, fostering an environment where curiosity and collaboration thrive. The vision of Pangaea can indeed be a guiding light for future scientists and explorers, urging them to unlock the mysteries of our planet in unity and purpose. The story of Pangaea, the supercontinent that existed over 300 million years ago, opens up a realm of existential questions about human life and our place in the vast cosmos. As we consider how this massive landform fragmented and drifted apart, we are reminded of the transient nature of all things. What does it mean for us as humans to inhabit a planet that is continually changing? The movements of Earth's plates remind us that nothing is permanent and that even the most stable environments can evolve dramatically over time. Reflecting on the existence of Pangaea raises profound questions about interconnectedness. At a time when all life on Earth was united on a single landmass, the diversity of species developed in isolation, shaping unique evolutionary paths. This historical perspective prompts us to contemplate the importance of connection in our own lives. How do our relationships and interactions shape our identities? Are we, like the continents, destined to drift apart, or can we find ways to bridge the distances that separate us? Moreover, the gradual breakup of Pangaea illustrates the concept of resilience in the face of change. Life adapted to the varied environments that emerged as the continents separated, showcasing the incredible ability to survive and thrive despite upheaval. For humanity, this raises questions about adaptability. As we face challenges such as climate change, social upheaval, and technological advancement, how will we respond to the inevitable transformations around us? Can we learn from the Earth's history to foster resilience in our own societies? Lastly, the history of Pangaea nudges us into a broader consideration of time and legacy. Each geological shift influences not just the Earth's landscape, but also the very fabric of life that emerges and evolves. When we reflect on our place in this grand timeline, it brings to light the question of what kind of legacy we wish to leave behind. As we navigate our fleeting existence in this ever-changing world, the tale of Pangaea serves as a poignant reminder of both our fragility and our strength within this majestic, interconnected web of life. Pangaea, the ancient supercontinent that existed around 300 million years ago, serves as a powerful symbol of global cooperation and unity. In its time, all the Earth's landmass was connected as one, embodying a vision of a world where differences weren't barriers, but rather part of a greater whole. Just as Pangaea represented a time when the continents functioned as a single entity, so too can it inspire contemporary efforts for international collaboration. When we look at Pangaea, we can appreciate how the landmasses shared ecosystems, climates, and resources. This interconnectedness laid the groundwork for diverse life forms that thrived together. Similarly, human societies, when united, can solve global challenges like climate change, health crises, and poverty. The metaphor of Pangaea encourages us to remember how interconnected we are in this modern world, emphasizing that together we can create solutions that benefit all of humanity rather than just individual nations or groups. Moreover, the eventual breakup of Pangaea serves as a reminder of the challenges posed by division. As the continents drifted apart, they became isolated, leading to unique regional developments but also creating barriers to cooperation. In our world today, the fragmentation of communities and cultures can lead to misunderstandings and hinder progress. By recognizing our shared roots, similar to those ancestral landscapes of Pangaea, we can work to bridge gaps and foster a spirit of collaboration. Embracing the essence of Pangaea means envisioning a future where global efforts are fueled by unity, mutual respect, and understanding. It reflects the belief that despite our diverse backgrounds, we have much to gain by coming together and working towards common goals. In this way, Pangaea remains not just a relic of Earth's geological past, but a compelling metaphor for the potential of our global community today. The concept of Pangaea, the supercontinent that existed around 300 million years ago, invites us to reflect on the dynamic interplay between Earth's geological history and the rise of human civilization. Pangaea challenges our perception of human dominance over nature by reminding us that the planet has gone through tremendous transformations long before humanity even existed. This vast landmass united what are now separate continents, showcasing a world where ecosystems thrived and life flourished under different circumstances. As we see today, continents are not static. They drift and reshape the planet's surface over millions of years. This movement is driven by the tectonic processes that continue to occur beneath our feet. The formation and eventual breakup of Pangaea illustrate not only the power of nature to reshape itself, but also the relatively brief moment that humans have occupied the Earth. While we may feel like masters of our environment, the geological timescale and the history of Pangaea remind us of our place in a much larger narrative. Moreover, The biological consequences of Pangaea present another fascinating aspect of nature's superiority over human control. The convergence of different species on this single landmass contributed to remarkable evolutionary processes and biodiversity. Cities and civilizations may rise and fall in the blink of an eye compared to these deep biological connections that have taken millions of years to establish. Nature's intricate web of life can flourish or collapse independently of our aspirations as humans. Ultimately, the story of Pangaea serves as a powerful lesson in humility. It highlights that we are but a small part of Earth's ever-changing tapestry. Despite our technological advancements and developments, we are still subject to natural forces far beyond our control, a fact that continues to resonate in our ongoing discussions about environmental stewardship and sustainability. As we reflect on Pangaea, we are reminded to respect and coexist with the natural world, for it was here long before us, and it will remain long after we are gone. The concept of Pangaea, the supercontinent that existed approximately 300 million years ago, offers a fascinating lens through which we can explore our understanding of continental and cultural identity. As Pangaea broke apart, it set the stage for the continents as we know them today, influencing the geographical and cultural landscapes of our world. The traces of this ancient landmass serve not only as a geological marker, but also as a reminder of our shared origins. From a geological perspective, Pangaea shows us that the continents were once connected, suggesting a deep kinship among the landmasses we now perceive as distinct. This historical interconnection can shape our perspective of identity, emphasizing that the boundaries that divide us today are relatively recent phenomena. For instance, the alignment of certain mountain ranges and rock formations across continents highlights how Earth's natural fabric once wove diverse cultures together even before they evolved into distinct groups. Culturally, the idea of Pangaea fosters reflections on how human communities developed in the context of shifting landscapes. As groups migrated across what we now recognize as separate continents, they brought with them diverse languages, traditions, and customs. The remnants of ancient connections remind us that cultural exchanges were common across regions, influencing everything from art forms to agriculture. This historical narrative challenges the notion of cultural isolation, illustrating how interconnected our world has always been. Ultimately, Pangaea encourages us to view our identities through a broader lens. It invites us to recognize that while we may define ourselves by our national, ethnic, or regional affiliations, there is a shared heritage that ties us to one another. Understanding Pangaea helps frame our modern narratives about identity, reminding us that as our continents drifted apart, we carried with us pieces of our collective past, a past that continues to shape our interactions and perceptions today. The story of Pangaea, the ancient supercontinent that existed nearly 300 million years ago, evokes a range of emotional responses, illustrating both the wonder and the melancholy of Earth's history. To imagine a time when all the continents were united into a single landmass can ignite a sense of awe. This vast, interconnected landscape is a reminder of the dynamic nature of our planet, shaped by powerful geological forces. The idea that the familiar continents we know today were once part of a colossal landmass can spark curiosity about how Earth has changed over eons and the processes of plate tectonics that continue to influence our world. Furthermore, there is a bittersweet realization associated with Pangaea as well. The fragmentation of such a magnificent unity into isolated continents resonates on a personal level. It reflects themes of separation and change, reminiscent of human experiences of loss and reconnection. The shifting of landmasses leads to the extinction of certain species, reshaping ecosystems and altering the course of evolution. This aspect of Pangaea's story reminds us of the fragility of life on Earth and the inevitable changes that come with time. Additionally, the narrative of Pangaea encourages a sense of connectivity across our planet. In modern times, as continents drifted apart and cultures evolved in isolation, humanity still seeks to bridge these divides. The knowledge that the land beneath our feet was once part of a larger whole might inspire people to look beyond geographic and political boundaries. It serves as a powerful metaphor for global unity, suggesting that though we may have drifted apart, there still exists a common origin worth celebrating. Ultimately, the story of Pangaea invites a blend of emotions, from awe to nostalgia, instilling a sense of appreciation for our planet's intricate history. As we contemplate the ancient past and the forces that shaped it, we are reminded that both nature and humanity are in a constant state of flux, weaving together a rich tapestry of life and connection across the ages. Understanding Earth's distant past is like peering through a window into our planet's intricate history, a history that deeply informs our present and guides our future. By exploring geological records, fossil evidence, and ancient climates, we begin to grasp the dynamic processes that have shaped the Earth over millions of years. This knowledge empowers us to recognize patterns, discern ongoing changes, and comprehend how life has thrived and adapted through various epochs. Take, for example, the study of ice cores from Antarctica. These cores hold invaluable records of atmospheric composition over time, revealing how carbon dioxide levels have fluctuated with natural cycles. By comparing those times of high carbon levels with current and projected scenarios, scientists can better understand potential climate outcomes. A clearer picture of how ecosystems responded to climate change in the past offers crucial insights as we face similar challenges today. Furthermore, understanding past extinction events, such as the demise of the dinosaurs, highlights the fragility of life on Earth. These events often resulted from significant shifts in climate and habitat destruction, often exacerbated by external factors like asteroid impacts. By studying these patterns, we learn the importance of biodiversity and the interconnectedness of species, prompting us to take action to protect our current ecosystems. The lessons from Earth's past are not merely historical footnotes, they are essential for envisioning a sustainable future. By grasping how past changes can lead to dramatic shifts in climate and life, we become better equipped to make informed decisions today that can positively affect the Earth for generations to come. This deep connection evokes a sense of responsibility, urging us to nurture our planet as stewards for the future. Pangaea, the ancient supercontinent that existed around 300 million years ago, provides a fascinating backdrop for fictional narratives. Its vastness can inspire stories that stretch across sprawling landscapes, teeming with unique flora and fauna. Imagine a world where towering mountains, extensive deserts, and lush forests coexist, creating a rich tapestry of environments. Such a setting allows for diverse ecosystems where characters can interact with creatures that have long since vanished, offering a gateway to adventure and exploration. Moreover, the idea of Pangaea evokes a sense of unity and connection. At a time when all land masses were joined, it sparks intriguing themes of cooperation and conflict among different groups of people inhabiting this colossal land. Writers can delve into the lives of ancient civilizations, portraying their struggles, alliances, and cultural exchanges. The shared landscape could lead to rich narratives about how geography shapes relationships, survival strategies, and even belief systems. Furthermore, Pangaea's eventual breakup creates dramatic potential for storytelling. The shifting continents, breaking apart under immense geological forces, can serve as a metaphor for change and transformation. This scenario can symbolize themes of loss and adaptation, as characters must navigate not only physical divides, but also emotional and societal rifts. The storylines can explore how communities react to these upheavals, fostering resilience and innovation. Lastly, the dramatic climate changes that occurred during the time of Pangaea can add another layer of intrigue. Writers can use extreme weather events, volcanic eruptions, and shifting habitats to enhance the tension and stakes in their narratives. This setting encourages characters to face both internal and external challenges as they learn to thrive in an unpredictable environment. By harnessing the context of Pangaea, storytellers open the door to a realm where the natural world intersects with human experience, making for compelling and thought-provoking tales. The ancient land of Pangaea, a supercontinent that existed around 300 million years ago, invites the imagination into a world rich with drama and natural splendor. One could envision a tale of early life, where diverse ecosystems flourished, giving rise to extraordinary creatures. Imagine a community of early mammals struggling against the backdrop of massive ferns and towering conifers, all while dinosaurs roamed their world, casting long shadows across the landscape. Picture a group of explorers, perhaps a tribe of early humanoids, who venture into the heart of Pangaea in search of new resources. As they traverse this vast land, they encounter both adversity and awe. They might come face to face with colossal reptiles, experiencing the raw power of nature's might. These encounters provide the perfect stage for stories of survival, ingenuity, and the bond between humans and the environment. The dramatic shifting of Pangaea could also play a pivotal role in these stories. As tectonic plates began to move, splitting the land apart, the characters can experience not only the physical upheaval of their world, but also the emotional turmoil that accompanies such changes. Families might be torn apart by the encroaching seas, and groups could be forced to migrate in search of new lands, creating tension and opportunity for growth. Moreover, the immense volcanic activity of that era could set the scene for tales of caution and courage. A volcanic eruption could threaten entire communities, prompting tales of heroes who lead their people to safety amidst the chaos. Whether framed through the lens of environmental change or the daily struggles for survival, stories set on Pangaea could illuminate the resilience of life and the interconnectedness of all living beings, laying the groundwork for our understanding of survival in a changing world. Pangaea, the ancient supercontinent that existed around 300 million years ago, offers a rich narrative thread for artists immersed in visual storytelling. The image of a world once unified, where diverse ecosystems and climates thrived side by side, serves as a canvas ripe for creativity. Artists can envision vast forests teeming with life, soaring mountains and expansive deserts, all interconnected in a way that contrasts sharply with today's fragmented continents. This captivating imagery provides fertile ground for depiction, inviting audiences to journey through time and explore the planet's geological and ecological evolution. Furthermore, the concept of Pangaea evokes themes of unity and separation, which resonate deeply with the human experience. Artists can portray the emotional and physical disconnection that arises when environments drift apart, mirroring relationships and communities that once thrived together but have since become isolated. By using Pangaea as a metaphor, visual storytellers can communicate feelings of nostalgia, loss, and hope, presenting a powerful commentary on our modern societal dynamics and the environmental crises we currently face. Notably, Pangaea is also a visual feast for imaginative interpretations of ancient life. Artists can delve into the prehistoric past, depicting the diverse array of creatures that roamed the land, from colossal dinosaurs to vibrant flora. This exploration can not only educate viewers about biodiversity, but also spark a sense of wonder about the evolutionary processes that shaped life on Earth. Through their art, creators can invite audiences to marvel at the intricate connections between the past and present, highlighting how the remnants of Pangaea still influence our world today. Pangaea's allure as a subject for visual storytelling lies in its dual capacity to evoke both awe and reflection. It encourages artists to weave narratives that bridge the ancient with the contemporary, fostering a deeper understanding of our planet's history. By exploring these themes, artists not only celebrate the beauty of the Earth, but also challenge viewers to engage thoughtfully with the legacy of our ever-changing world. A science fiction story set during the time of Pangaea could delve deep into human nature by exploring themes of survival, adaptation, and the complexities of social structures. Picture a world where the continents are united, creating vast landscapes that are teeming with life, but also rife with danger. In this speculative setting, the story could focus on early humans, depicting their struggles and triumphs as they navigate the interplay of environment and instinct. The challenges of living in such a unique ecosystem would highlight key elements of human nature, such as cooperation and competition. Communities might form around the resources that their environment offers, showcasing the emergence of social bonds and the ways in which individuals learn to trust one another. Conflict could arise from both scarcity and abundance, pushing characters to confront their instincts, either to hoard resources or to share for the greater good. Furthermore, the story could examine the clash between different groups of early humans. As they move across this colossal landmass, encounters could spark tension, prompting questions about identity, belonging, and the essence of humanity itself. Would these groups choose isolation for safety or seek collaboration to enhance their survival? The relationships forged or torn asunder could serve as profound reflections on the basic tenets of empathy, rivalry, and the thirst for unity in the face of adversity. Additionally, a backdrop as dynamic as Pangaea could introduce the concept of change, both physical and societal. As the landscape shifts with tectonic movements, so too could the characters evolve, both physically and psychologically. The breathtaking landscapes would serve not just as a setting, but as a character in its own right, influencing the choices people make and shaping human nature in unexpected and revealing ways. Through this lens, the narrative could offer rich insights into how the distant past informs our present understanding of ourselves. Pangaea, a supercontinent that existed around 300 million years ago, serves as a fascinating backdrop for examining themes of survival and adaptation. At that time, the Earth was a dramatically different place, with sprawling land masses connected and vast oceans separating them. This unique configuration influenced not just the climate, but also the diverse ecosystems that existed, compacting various habitats into a single land area. In this primordial world, organisms faced the colossal challenge of adapting to a multitude of environments ranging from arid deserts to lush forests. The theme of survival highlights the resilience of life during a period of significant geological and climatic changes. As Pangaea began to break apart, many species were thrust into new environments, forcing them to adapt to conditions they had never encountered. For example, as the climate shifted and sea levels changed, species that thrived in wet environments might have faced drought, prompting adaptations like deeper roots or water conservation mechanisms. On the flip side, those in arid regions may have evolved traits to exploit newly created coastal areas or tropical forests, showcasing the incredible versatility of life in response to change. Adaptation also encompasses the evolutionary arms race that unfolded on Pangaea. With species competing for resources, some developed specialized diets, while others honed physical traits for hunting or evading predators. The competition led to biodiversity, with various niches being filled as organisms adapted to their specific surroundings. The story of Pangaea, thus, is not just one of survival but of transformation, where life continually evolved in reaction to its environment and the challenges it faced. Today, the legacy of Pangaea remains evident in the shared characteristics of species found across distant continents. The evolutionary pathways that began on this supercontinent continue to intrigue scientists as they map the journey of life through time. Pangaea was not merely a landmass, but a crucible for life's incredible ability to survive and adapt, setting the stage for the rich tapestry of biodiversity we witness today. The ancient supercontinent of Pangaea presents a fascinating setting for fictional characters to learn profound lessons about adaptability and resilience. Living in an era where the land and climate were in constant flux, characters could observe how species thrived by learning to adapt to transformations in their environment. Whether facing shifting climates, changing ecosystems, or the gradual separation of land masses, these characters would come to understand the importance of flexibility and evolution, not just in the biological sense, but in their personal growth as well. Moreover, the dynamics of Pangaea would teach characters about community and collaboration. As different species coexisted in this vast land, they had to form alliances and understand one another to survive the constantly varying conditions. This could inspire fictional characters to appreciate the strength found in diverse relationships and how working together can lead to survival and success, even in the face of adversity. Additionally, Pangaea's eventual breakup reminds us all of the inevitability of change. Characters witnessing the gradual drift of continents could develop an understanding that change is a natural part of life. This realization can lead to transformative insights about accepting loss and embracing new beginnings. The stories of transition, whether they are personal or environmental, can become a powerful way for characters to reflect on their journeys and the interconnectedness of all life. Finally, the dramatic landscapes of Pangaea, with its towering mountains and vast deserts, exemplify the awe and beauty of our planet. Characters could learn the importance of respecting and preserving the environments in which they live. Engaging with the geographic diversity and its impact on life would instill a deep appreciation for nature and the need to protect vulnerable ecosystems even today. Through these lessons, characters would emerge stronger, wiser, and more attuned to the world around them. Music and art offer powerful mediums for diving into the ancient history of Pangaea, the supercontinent that existed hundreds of millions of years ago. Through creative expression, artists and musicians can evoke the awe and mystery surrounding the formation and eventual breakup of this vast landmass. Imagine intricate paintings depicting the lush jungles and towering mountains that once shared space, or sweeping musical compositions that reflect the grand movements of tectonic plates. These artistic interpretations allow audiences to visualize an era that is not just about geology, but also the vast potential of life that thrived during that time. Art can serve as a time capsule that transports viewers back to when Pangaea was alive with diverse ecosystems. Sculptures and visual installations can reflect the flora and fauna adaptations that emerged across its expanse. For example, intricate designs might symbolize the ancient forests that dominated its surface, or the unique animals that roamed its lands, bridging the gaps of time and offering a glimpse into a world that once existed. This visual storytelling can spark curiosity, encouraging individuals to learn more about prehistoric environments and the scientific discoveries that detail how Pangaea transformed. Meanwhile, music can evoke the emotional landscape of this ancient time. Composers may draw upon natural sounds or create melodies that mimic the Earth's movements, suggesting the rhythmic shifts as continents drifted apart. The sound of crashing waves can represent the oceans forming as Pangaea splintered. The emotional resonance of music can illuminate the geological story, connecting listeners to a time when the boundaries of the planet were vastly different from what we know today. By combining both art and music, they create a multi-sensory experience that makes the history of Pangaea palpable for listeners and viewers alike. These expressive forms can educate and inspire, transforming scientific concepts into deep, lasting impressions. Ultimately, they provide a compelling narrative that highlights the interconnectedness of art, music, and the natural world throughout time. The concept of Pangaea, the supercontinent that existed hundreds of millions of years ago, provides a fascinating lens through which to reinterpret ancient myths. In many cultures, myths often explore themes of unity and separation, creation and destruction. Pangaea, as a symbol of a time when all land was connected, can serve as a backdrop to these themes, suggesting that ancient peoples might have had a profound understanding of interconnectedness long before the advent of modern science. Imagine a myth where the Earth was once a seamless realm, teeming with diverse life and cultures. As the story unfolds, the land gradually fractures and separates, leading to the formation of distinct continents. This physical division could represent the emotional or social rifts we witness in human relationships. By invoking Pangaea, we can reimagine these tales as metaphors for unity and the human experience. It portrays how, despite our separations, we share common origins and a shared fate, highlighting the importance of reconnection and understanding in today's fragmented world. Additionally, Pangaea can invoke themes of climate change and environmental stewardship. Myths often reflect the relationship between humanity and nature, and the tale of a united landmass could be interpreted as a warning. As Pangaea broke apart due to geological dynamics, it serves as a reminder of nature's power and the consequences of ecological disruption. By merging these ancient narratives with contemporary issues, we encourage a dialogue about how our actions today can affect the planet tomorrow. Ultimately, reinterpreting Pangaea through the lens of ancient myth fosters a deeper appreciation for our shared history and collective responsibility. It reminds us that the threads of life connect us all, just as the continents were once joined. Through this perspective, we can both honor our rich storytelling traditions and address the pressing challenges that define our age. Imagining a new narrative centered around Pangaea offers a fascinating opportunity to reshape how the public understands geological history. Pangaea, the supercontinent that existed over 200 million years ago, serves as a compelling chapter in Earth's story. By emphasizing its formation and eventual breakup, a fresh perspective can highlight the dynamic processes that have shaped our planet's surface over immense timescales. In this narrative, Pangaea could be depicted not just as a static landmass, but as a thriving ecosystem where diverse flora and fauna coexisted. This view could illuminate the interconnectedness of species and the environments that existed during that time. By showcasing how geological events like continental drift influenced evolutionary paths, we can provide audiences with a clearer picture of how the Earth's shifting plates have shaped not only landscapes, but also the very fabric of life on Earth. Moreover, a contemporary story of Pangaea might connect past geological shifts to current environmental issues. As we face challenges such as climate change and habitat loss, understanding the historical context of Pangaea's formation and dissolution can remind us of Earth's resilience and also its fragility. It can serve as a sobering reminder that while Earth is a constantly changing system, it is also one that can rebound from significant disruptions. Lastly, this refreshed narrative could inspire a broader appreciation for geology in the context of human history. By integrating the story of Pangaea with cultural and scientific developments, we emphasize how deeply intertwined human civilization is with Earth's geological history. This can foster a sense of stewardship towards our planet, as audiences see themselves as part of a long narrative that connects the past, present, and future. In a world reminiscent of Pangaea, where all land masses are connected, the motivations of its inhabitants can be deeply influenced by their unique environment. First and foremost, survival stands at the forefront. The inhabitants would be driven by the need to secure resources such as food, water, and shelter. In such a vast landscape, opportunities for hunting and gathering might promote mobility, leading individuals or groups to constantly seek out new areas rich in resources. This quest for survival would foster a strong communal spirit among the inhabitants, as cooperation becomes crucial for overcoming the challenges posed by nature. Additionally, the interconnected geography of a Pangaea-like world could spark curiosity and exploration. With vast terrains to traverse and diverse ecosystems to discover, characters might be motivated by the desire to unearth the secrets of their world. The allure of adventure might inspire them to chart uncharted territories, driven by a sense of bravery or even mere wanderlust. This desire to explore not only enriches individual experiences, but also strengthens cultural ties as stories and knowledge are shared among communities. Cultural exchange would also play a significant role in this setting. With people from different regions living in proximity, trade and interaction would naturally thrive. Motivations could shift towards forging alliances or forming trade networks, as exchanging goods and ideas would enhance their quality of life. Such interactions might lead to the emergence of complex societies, where social status and political power become essential motivators for characters seeking to improve their standing in the community. Finally, the spiritual or philosophical dimensions of existence could deeply influence the motivations of these individuals. In a world abundant with natural wonders, characters may find meaning in their connection to the land and its cycles. This reverence for nature could manifest in rituals, storytelling, or art, driving them to seek a deeper understanding of themselves and their place within the grand tapestry of existence. Therefore, the motivations in a world like Pangaea's could range from basic survival to higher pursuits of knowledge, connection, and meaning, providing a rich and varied tapestry of human experience.